In this lecture, we will be looking at the regulars and non-regulars. Before starting the regulars and non-regulars, what we have completed in the previous session, which is regular expressions and finite automata along with the basics. And also we will be seeing non-deterministic finite automata along with the regulars and non-regulars in this video. And once we complete regulars and non-regulars, we will be looking at closure properties of regular languages in the next video. So let me begin with regulars and non-regulars. First, let me talk about the language so that you will get to know what is regular and non-regular. When we look at the language over any sigma, you will be having the two cases, right? Finite language and infinite language, or you can say finite set or infinite set. If the language is finite, no doubt you can always write a regular expression, or you can design deterministic finite automata, or you can design non-deterministic finite automata. So we can believe that every finite automata, every finite language is regular, because you can always design a finite automata. But that doesn't mean that every regular language is finite language. Let me write here finite set and infinite set. It's not true that every regular language is finite set. What you can say, every finite set is regular, but regular may be finite or maybe sometimes infinite. So in the infinite, we have two cases. Some languages are regular, some languages are non-regular. So we are going to learn these three cases where finite languages are always regular, but some of the infinite are regular, some of the infinite are non-regular. Under which cases the infinite languages are regular, and under what condition the languages are non-regular, we are going to learn. Okay, so here we will be focusing on the mainly infinite languages. Of course, whenever the language is finite, it's very easy to say it is regular, but only the thing is, infinite languages we require the conditions, or we require the regular expressions or finite automata to understand whether we have the representation for the given language. Okay. Sorry. Here I'm going to talk about the language in terms of regular and non-regular. As I told you, if the language is finite, straight away you can say regular. Okay, no confusion at all. We have a lot of cases. You can say regular language or set. Language also called as what? A set. Fine. So what are those languages which are finite? Suppose you have a power n, b power n, such that n less than 100. Because we'll see in the practice, but just for an example. Or you have a language, let's say you have only few strings like epsilon a, b. These are the finite languages, right? Where the number of strings will be finite. So I have just given two examples, but you will be seeing a lot of examples in the practice. Now when the language is infinite, how many cases you will have? There are many cases that we are going to learn. Is it having over one symbol? Language is over one symbol? Then we need to look at few things. Of course, right now don't worry, we will have a lot of examples. It means language is over one symbol. If the language is over one symbol, you need to look at two conditions. One, forming AP or not. the strings of the language will form arithmetic progression, then that language will be regular. For that, you have a lot of examples, like you have A star or double A whole star. So many such examples you will be seeing soon. But right now, remember, when the language is over one symbol, we have something to check. That is, whether it is forming, or the strings of the language forming arithmetic progression or not. If they are forming arithmetic progression, we can say, or we will say, it's regular. In case not forms AP, not forming arithmetic progression, then we will say not regular or non-regular. So this is a special case. Whenever the language is having over one symbol, but it is a finite, then don't check all these things. Just say anything, whether it is over one symbol or more than one symbol. In case it is a language is finite, then it is always regular. We don't check these two conditions. These two conditions we will check only when language is infinite and having one symbol. If it is not having one symbol, so definitely it should have more than one symbol, like the alphabet size should be greater than 1. That means 2 or 3 or 4 more or more. Then you will have something to check. The symbols of the language, do they have dependency? That's a very important point. If no dependency between the symbols, then we say language is regular. Remember, when it is having more than one symbol and having no dependency, then it is irregular. In case if you see dependency, or if you see something like not forming AP over one symbol, because in that more than one you will be having some symbols which do not form AP, then it is also not regular. You may see dependency between the symbols. What kind of dependency we will see it later. It's not a finite dependency. The dependency should be there till infinite. That is the meaning dependency here. The dependency, or sometimes some of the symbols do not form AP. Some of the symbols not forms AP, or both might be possible. In that case, the language is not regular. So you may ask, sir, give me an example so that I will understand all these cases. Let's see. Even though I'm going to explain each case later, but let me give an example. I have given the languages which are forming AP over one symbol. I have given here not forming AP but not regular. You can think about A power prime. I'll be taking this example later on, but just I'm giving one example to categorize this case. And there is no dependency like A star, B star. The language is infinite and more than one symbol like A and B, but having no dependency. Yeah, right? Number of here, all the A's followed by all the B's. Here, either dependency might be there or may not form AP, or might be both. Example is dependency. You may write A power n, B power n. You see that? Of course, the n is greater than or equal to 0. Don't write like this, n less than 100. If you write n less than 100, that goes to this category, right? This case. Now, is one example where A's and B's are dependent to each other till infinite. So that case will come under non-regular. Is there any example which is not forming AP but having more than one symbol as? Where suppose I have A star, B star. See, and then I'm just writing C power prime. See that? Even though I don't have a dependency here, A's, B's, C's, they have no dependency. How many A's, how many B's, how many C's? We don't have dependency on each other. But C is not forming AP. That's why this language is going to be non-regular. Sometimes it could be possible dependency is there and also not forms AP. That example is here A power n, B power n, let's say C power prime. See that A and B are depending on each other and C is not forming AP. So all these cases will come under here. Definitely they are not regulars. So we are going to learn these cases. to understand whether the language is regular or not. Okay, let's begin with this. You will be having an idea like under which cases you will be seeing the regular. The problem is, don't assume that you know the concepts, right? Right now it's nothing happened. Just I'm saying the overview of the regular concept. But when I give a language, identifying the case is really difficult for you because you need to observe the strings of the language. But I may not give the strings, right? I will give you some form like W, W, X, some form I will give. But bringing the strings from that form is challenging for us. We will always look at whether the strings of the language, when we look at number of strings finite, then comes under this case. If you have over one symbol, the strings of the language are forming AP, then it's regular. Strings of the language not forming AP, then it is not regular. And within the strings, if you see any string, or within the strings, if you see some common property like there is no dependency, you take any string, there is no dependency between the symbols till infinite, then we say regular, like you see here. But if there is a dependency till finite, we don't care that, right? Dependency might exist till finite. Look at that. You have a dependency but till finite, right? You may say, sir, do you give an example? I have the finite dependency but still it is regular. Yes, I can give here a power n b power n c star, where n less than 100. See here, I have no dependency. Don't call it as a dependency. Looks like a and b are having same count, right? But it's coming up to finite, up to 99 only they are coming, right? So such cases it's fine. This dependency we are talking about infinite dependency. If there is no infinite dependency, or dependency is not present till infinite, then we say it is regular. If the dependency present till infinite or not forming AP, or both are present, we will be saying not regular. I hope you have a clarity in this concept. But first thing is, understand the given language, then categorize or put into the particular case, in case if it is possible for you. Okay. The first question is a power m b power n, such that m and n is at least 1, or you can say greater than 0. So whenever I give the language, your focus is on, can you design a DFA, or can you write an expression, or what case it is going to be in the given concept. Okay, now do you have any dependency? No. So can I write some expression like a plus b plus? Can I write it or not? See that a is greater than 0, b's power is greater than 0, then that must be a plus b plus. That's positive closure of a followed by positive closure of b, or you can say at least 1a followed by at least 1b. So this kind of the language is definitely having regular expression, so you can design a finite automata, hence it is regular. It may not be this one, you may have a various example. Okay, sometimes one example would be sufficient to understand various other examples like a power m b power n, such that m greater than 5 comma n greater than 10, doesn't matter, but concept is same, right? Concept is same. You can also write this language as it's m greater than 5, means at least 6 will be there, right? So a power 6 is minimum, plus let's say I, b power greater than 10 means at least 11 plus j, so that I comma j greater than or equal to 0. You can write some other way, say this language. So this language is also having regular expression. You can write regular expression now. A power sorry, a power 6, that after that any number of a's can come, and b power 11, after that any number of b's can come. So this is definitely a regular expression. Whenever I am able to write regular expression, the language is always a regular, because both are equivalent. For the given language only I have written regular expression, so that you can design finite automata for this too. Similarly, you can write your own conditions, but that should give you property of regularity. Okay, let's move to the another problem. Focus on this. Okay, can you write regular expression for this? Try it. Looks impossible. You can't write regular expression for this, because m and n here, number of a's and number of b's. Try to write the strings now. epsilon. As you know, if I don't mention the condition what is m and n, then they always starts with 0. So when you put a power 0, b power 0, you will get epsilon. Then a power 1, b power 1, that is ab. Then a square, b square, that is double a, double b. And a cube, b cube, because m and n are same. So somebody can write this language as a power n, b power n. What they can write? A power n, b power n, where n is greater than or equal to 0. Here 3 a's, 3 b's, 4 a's, 4 b's, and so on. Now, do you see in every string there is a dependency, and that dependency continues till infinite. Okay, till infinite the dependency exists. So the language is non-regular. So what condition you are seeing here? If you look at the number of a's and number of b's, dependency exists. But dependency is only up to some time. For some time only, no, right? Dependency exists till infinite, till infinite. It need not be from the first symbol, but first string. It could be from any string, but till infinite the dependency preserved. So it is not regular. And in which case the language is over more than one symbol and having a dependency. That is the last case that we have seen. Okay, similarly, you may see like this one is a power n, b power n, right? In future you will see like a power n, b power 2n, or a power 2n, b power n, so on. It's not just 3 examples, right? A power 3n, b power n, or a power n square, b power n. Any such things will be coming under this. Okay, you will be having dependency between 2 symbols, but sorry, unless you keep the value of n is finite. If I keep in all of them n less than 100, then all this is going to be finite languages, and dependency is coming up to finite time. So definitely the language is going to be regular. So always look at what is the value of n. Is it limited or unlimited? If n is going to be reaching without a condition, or n is greater than 10 or greater than 5, greater than 0, if you see such things, then there will be dependency till infinite. I hope you understood the examples. For this, maybe I have taken one example, but at the same time I'm giving a lot of variations which are similar to this problem, and all these languages are non-regular when you don't have a restriction on n. Okay, what is the next? Okay, now we have a restriction, right? Looks like there is a dependency, but you see the language is finite. Yes or no? Epsilon, a power 1, b power 1, a power 2, b power 2. How long you have this count possibility for between a's and b's? Till 99 only. A power 99, b power 99. So after that, there is no string. Means total number of strings here 100. So 100 strings present in the language is going to be finite language. Which language it is? Finite. You may ask that even though it is a finite language, how the DFA will check this a power and b power? And no, DFA will not check. DFA will accept the strings. You need to design a DFA, but that is the only form of the language. DFA will not try to understand what is this n value, what is this a power, right? It will only take the strings, and you need to design the DFA such a way that it will accept all the strings of the language. Okay, so it is regular because the language is already finite. In case if you see the examples that I have given, a power n, b power 2n, such that n less than 5 or n less than 100, doesn't matter what count you have, n less than 100 power 100, still it is a finite language. Okay, a power n, b power, okay, a power 2n, b power 3n, where n less than 10 power 100 power 1000, doesn't matter how do you write, right? All these languages are finite, right? These all languages are going to be regular. Maybe it will take time to design a DFA or prove that it is regular, but by using the concept you can understand it is regular. Fine. Another one, a power n, b power n, okay, where m is even, n is odd. Okay, the problem here is the m, just change here, the a power is m So a power m, b power n, such that m is even and n is odd. In this case, how do you understand it is regular or not? You can try writing a regular expression so that you can conclude this is regular. Okay, I'm trying regular expression. When m is even, that means number of a's is even. When number of a's is even, right? Number of a's is even. Only a's, how do you represent? Double A whole star. Without a b, without a b. And number of b's is odd. How do you represent? Number of b's is odd. B whole star, this will be even, and if you add one more b, either left or right to this expression, will become odd number of b's. So you know individually how to represent even a's and how to represent odd b's. Now you have got a chance here to represent them. A power even. How do you write a power even and b power odd? So this a power even I can write as double A whole star, and b power odd I can represent using b followed by double B whole star, and this expression is regular expression, right? So you can always design a DFA or finite automata to accept this language. We have already seen in the lecture 1 that even number of a's and odd number of b's we have designed a DFA. Not only this, even number of a's, even number of b's, odd number of a's, odd number of b's. Total 4 states required to accept this language. Yes or no? So definitely this language is regular. And I'm saying here, not only this, in case you have a problem like a power m, b power n, such that m is equal to odd, language may change, the strings may change, but answer is always regular here. M is equal to odd, n is equal to odd. Same 4 states will be there, but final states will be different if you design a finite automata. M is equal to odd, n is equal to even, or both can be even. All these problems are regular. Okay. Let's move to the next one. A power m, b power n, where LCM of m comma n is 2. Now you need to understand how many possibilities are there for m comma n so that the value is 2. If m or n goes beyond 2, definitely LCM impossible to become 2, right? So let's try first. What is this LCM? So that you can find the possible values for m and n. I'm just trying m value and n value. If both one is m is 1 and n is 2, yes, LCM is 2. Or you have other choice, m is 2 and n is 1, right? Then also you get possibility 2. Is there any other values for m and n so that the LCM of m comma n is 2? No, only we have 2 possibilities. Either it will be 1 comma 2 or 2 comma 1. It means the language is going to be a power 1, b power 2, or a power 2, b power 1. Now somebody want to say only 2 strings, but they formed a different condition to say that I have 2 strings. I can directly say the language is ABB comma double AB, but I didn't say that. I said a power m, b power n, such that LCM of m comma n is 2. So that means it is nothing but 2 strings. The language is finite, is always regular, right? So when we design a DFA, it is not going to check LCM. As you know, it's just a representation of a language. But for the DFA, you can't give this language as an input. What do you give? You will give string as an input. So you should know how to design a DFA for this problem, correct? Language is regular. Language is regular. Maybe in the future you will see LCM of m comma n is equal to 100. It doesn't matter. You can say it is a finite language. You can say it is when less than or equal 100 or equal to 100. But if I say greater than or equal to 100, yes, very difficult to say because you need to look at a lot of combination in that case. Of course, you may try it. So I'm giving homework for you in case if anybody says LCM of m comma n greater than or equal to 2, whether it is regular or not. So it's I'm giving homework for you. So how do you do that? First you try LCM of m comma n less than 2. How many cases are there? And except that strings, every other string should be accepted. So can you do that? Yes, you may try, you can do it. That's what I'm giving homework. There are various conditions you will get. Try this and prove me that it is regular. Okay. Next one. Oh, GCD. And what is the difference between LCM and GCD? LCM is a common factor, right? LCM is like HCF. LCM is like least. What is it? LCM is going to consider the common factors first, 2, 1, 2, and then you don't have anything, so you will get total 2 2s are 4. So here LCM, least common multiple you take, but when you do GCD, it's just like common factors you need to find out. So suppose I want to find out GCD of highest common factor, right? 2 comma 4. Then what is the highest common factor for this? 2 comma 4 is going to be 2. But you're not going to just do GCD. I want to find the GCD of two numbers is 1. GCD of these two numbers is not a 1. What do you mean by GCD of two numbers is 1? They must be co-prime to each other, then only you will get the 1. Okay. So let's see that. What are those numbers you will have GCD is 1? Let's say GCD of 2 comma 3. Is it 1 or not? Yes. GCD of 3 comma 2. Is it 1? Yes. GCD of 2 comma 5. Is it 1? Yes. GCD of 5 comma 2. Is it 1? Yes. When the two numbers are co-prime, then definitely you will be having m comma and GCD is 1. Now let's try how many such values you will have. A power 2, b power 3. Of course, what about 1? I forgot the 1. GCD of 1 comma 2, 1, 1 comma 3, and so on, right? So you have so many such things. Let's start with 1 first. A power 1, b power 2, a power 1, b power 3, a power 2, b power 1, or a power 3, b power 1, and so on. You can also take a power 2, 3, a power 2, b power 3, and so on. How many such strings are there which have the powers are co-prime? Infinite. And how do you do that? Is there any logic to find the two numbers are co-prime to each other? Is there any? No, right? So we don't know how to do that prime concept here. So it's going to be not regular. It means they are dependent each other. They are dependent. How long? Till infinite. So very important. Sometimes the dependency you can easily understand, like when I say a power n, b power n. Oh, looks like very easy. The count of a's are same as the count of b's, so you can easily speak. But here the count, discount, the a power count is depending on b power count with the help of GCD concept. So they should be co-prime to each other, then only their GCD is 1. Fine. Similarly, if I talk about a GCD of m comma n equal to 1 or not equal to 1, then both are going to be very difficult right now, right? So you should know not equal to 1 how to check it. So both the languages are going to be not regular. Okay, another interesting example. A power m, b power n such that m greater than n, comma m less than 10. Sometimes when you look at this, it looks very difficult to understand. As you know, these two conditions you need to put in a sequence. So do you have any sequence to understand easily, like m greater than n? So can I write n less than m? Both are same, right? N less than m and m already known as less than 10. It means you are going to get finite cases. That means that m is greater than n and this m cannot cross 9. So it's going to be m value when it is 9, that n can go up to 8 only, right? So when m is 8, that n value is going to up to 7 only. So similarly, when you have this 1, it will be 0. That's the last case you will be having, right? When m is 0, n you can't put. So these are the possible combinations of m and n. How many strings you have totally, right? Finite number of strings. This language is going to be finite language. So it is regular. So it is regular. In exam, you may see a different conditions like m less than, n less than 100, or less than or equal to n less than or equal 100. When still this language is what? Finite language only. Likewise, you can have different languages. As already we seen one a power n, b power n, such that n less than 100. It's already finite language. Both are similar, but here a power b power need not be same. Here a power b power always same. So similar languages, but the strings property or behavior is different. Okay, take time now. Think about, is there any possibility to say it is regular? Do you have any knowledge on this to write regular expression? Okay, think about the a power and b power. Their sum is odd. Under what circumstances the sum of two numbers is odd? So now here m plus n is odd. So tell me, whenever you say m plus n is odd, what are the possibilities you will get? This m plus n, I'm talking about. If one of them is even, other is odd, then the result is always odd. If both are even or both are odd, the result is even. So here you should have a condition even plus odd, so that result will be odd, or odd plus even. That's it. If both are odd, both are even, the result always even, right? Now we have only two cases. The L is, now you are going to collect like a power even, b power odd cases, union. You are going to do it with a power odd cases and b power even cases. Now you need to represent an expression for these two forms, because two forms are present in the same language. Now what is a power even? You already know that, right? Double a whole star. And b power odd, that means b followed by 2b's whole star, or union means plus in the expression, and a power odd means a followed by double a whole star, and b power even means double b whole star. Double b whole star. Now this regular expression can be converted to finite remainder using algorithms, hence the language is regular. Okay, it not only this m plus n is odd. Suppose, I'm just talking about other examples which are also regular, similar to this, like L is equal to a power m b power n, such that m plus n is equal to even. Even this is also regular, but in that case, what do you get? Even plus even is equal to even. How do you write m plus n, right? And odd plus odd is even. So these two conditions you need to consider now. Okay, in that case, a power even, b power even, plus a power odd, b power odd. So two cases you will get again, but these two cases are somewhat different from these two cases. Fine, that is also regular. Okay, think about now. The first time I'm changing something in the condition, can you identify that? Where do you see the change? Can I say starting with a? No, you should not. You should not do that. Starting with a is wrong. Starting with a is over a comma b, this language, but I did not give this. I have changed something here, right? A W, where W belongs to this one, means you will get B star A star here. Anyhow, this language is regular. You can design a finite automata for this because I've already written regular expression for this. So it is regular and I'm showing it is having regular expression. So look at the differences. Sometimes you write W belongs to A comma B whole star. In that case, it will be A followed by A plus B whole star. Even though it is regular, but when they ask design a DFA or find the number of states in DFA, these two problems should be considered carefully. Okay, even though you missed it is A plus B whole star or B star A star, right? Even though you missed that concept here, still you will get the right answer. But that doesn't mean that these two languages are same. No, even though these two languages are regular, the finite automata is different for both of them. Okay, and in case if I write small change in the first problem, in that problem if I write W belongs to, look at carefully, B star A star whole star. Oh, if I do that, these two are same. Okay, why they are same? Because when you write whole star here, this will become A plus B whole star. Then these two are exactly same. Now you will have A followed by A plus B whole star, because this form is same as A plus B whole star. You know that A plus B whole star is say equivalent to B star A star whole star. Okay, in the previous lecture I've explained the equivalent forms of A plus B whole star, but this is not A plus B whole star form, as you are missing the star above this expression, right? Okay, be careful in these cases. The next one, W belongs to A plus B whole star, where W starts with A. We have written expression, we have designed DFA for this. And what is an expression for this? W starts with A, so A followed by A plus B whole star. Right, starting with A, we will be having 3 states if we design DFA. Anyhow, it is regular language. There is no dependency. It is infinite. It is infinite. So many things you need to observe. It is infinite set, no doubt, but it is regular because it has no dependency. So you need to follow all these concepts when you try for the problem. In the exam, they may talk about it is regular but finite. Another time they say it is regular but infinite. You should have a clarity between the regularity and infinite. It is regular, we know, but it is also infinite language. Another one. I have changed again the condition. Please observe and read carefully what I am writing here. Am I writing always A comma B whole star? Okay, it's A B whole plus. Then how you interpret this? W starts with A. Okay, starting with A, but W belongs to AB whole plus. Then what happens? Will you write A followed by AB plus? It's wrong. Why? Because I didn't say AW. If I say like this is equal to AW, such that W belongs to AB whole plus, then you can write A followed by AB plus. That's fine. But now you can't do that. W belongs to AB plus. When I say this, always W starts with A. That means this is not required. It is already covered. This is not needed. It is already considered here. When you say W belongs to AB whole plus, everything you take from AB whole plus already starting with A. That is the reason the answer is L is equal to AB plus. So this is the most important concept, how you apply these conditions over the W. Clear? So in this case, A already there before W in the form, so A is there as a separate symbol, and W is all belongs to AB plus, so you copied it. But here W is only your form. In that form, you need to guarantee these two conditions. W should be from AB whole plus and it should start with A. When I take AB whole plus, is it correct? Is it always starting with A? Check it. AB. Okay, already started with A. And AB when you repeat twice, AB, AB. It's also started. So write whatever it, repeat AB at least one time, you will have the string always starts with A. Hence, it is regular because this AB whole plus is definitely irregular. Now, some questions are coming. You know, you have written expression, but sir, what is the finite automata for it? And what is the DFA for this? AB whole plus. What is the minimum string? AB. How do you design a DFA for this? A followed by B. The first criteria. If it is epsilon, you can keep initial state as a final, but I can't keep initial as a final because minimum string is AB. Now after this, every AB should reach final because AB can be repeated any number of times. After AB, then I just take the help of the state A, I come here, I come back, so AB I will go final, AB I will go final, so I can repeat any number of times that AB. Now is it DFA? No, you should make it DFA. But with this you understood it's AB followed by any number of ABs. This can be written as AB followed by AB any number of times. That's what I did it. AB followed by AB any number of times. Because once I got AB, I reached final. This is what I have done. Now to make DFA, B is missing. So what do? We go to dead state. Here B is there, but A is missing. You can't have A after one A. Immediately you can't see two A's in a sequence. And after B, you can't have a B, but you can have A. You will go to dead state. So this is the complete DFA will require 4 states. I'm just showing because this kind of problem I have not designed in the previous lecture. So I'm showing it. Practice it to understand how to design a DFA for AB plus. You may try for AB whole star. What is the DFA? How many states required? Very interesting. W belongs to AB whole plus and W does not start with A. About pause the video and try to answer it. What do you get? Will it really matches with the answer that I'm going to explain? So wonderful. Okay. So pause the video and try to think about what are the strings which do not start with A, but that must belongs to AB whole plus. So clearly given W belongs to AB plus and that should not start with A. Is there any such W that you can consider? It is, think about empty language. Oh, how is that possible? Right? See, you take any string in AB plus, AB whole plus, every string has already started with A. That's why in the previous question, the W starts with A already is there inside, so you don't need to check additionally. But now the explicitly you are mentioning, I don't want to start with A. When you say that, you will never have a string in the AB whole plus. Okay, W must be belongs to AB whole plus, and W should not start with A. Is that possibility? Sorry, AB whole plus. Is there any possibility? No, right? Every string you take from here, it is starting with A. You are saying that I don't want to start with A. That is impossible to have a string. So this language is empty. So somebody want to say empty language, but they formed some conditions to produce the same empty set. When the language is empty, definitely it is what? The regular expression you write pi, and DFA you design simply this one A comma B, and it is regular. Okay. W1, W2. What is it? W1, W2. Oh, it's not a string. It is a string form. There are two different things. We always consider carefully string form and string. String form will help you to write a string. So what is the string form you have here? W1, W2. It's not a string at all. The string is here, that when you put A's and B's here, you will see the string. So think your focus should be always on string, not on the string form. String form should be considered, but final conclusion should be based on the string. Okay. Sometimes string forms will help you to do are to answer the correctly and immediately, but not all the time. It's not a string. What is it? String form. Here W1 is belongs to a plus b whole star, W2 is also belongs to a plus b whole star. Both are independent. So somebody can write a plus b whole star dot a plus b whole star only when these two are not having any comparison, or they don't have any dependency kind. Okay, the W1 W2 they're not having any comparison mainly. Then you can write this is equal to what? A plus b whole star. That means somebody want to say it is just a plus b whole star, but they have written very difficult form. Actually you can simply write W such that W belongs to a comma b whole star. But they didn't write this. They wanted to make it complicated, so they have kept W1 W2 such that W1 W2 are any. So it is a regular and very simple language. Similarly, in future you may face different things like W1 W2 W3 such that W1 W2 W3 belongs to a comma b whole star. Still the answer is same, a plus b whole star, hence it is regular. Okay, okay, take time. And one of the important language now, WW such that W belongs to AB whole star, A comma B whole star, or A plus B whole star. Now it's WW. You see something here, right? Try to write the strings. What happens if you write epsilon here? Others should be epsilon. But when you write W1 W2, both are different. If you write epsilon, this you can write anything. You can write epsilon, you can write A, B, W, anything you can write. So this whole thing can come with epsilon. So they are completely independent. But here these two positions are dependent. If you write W side epsilon, other W should be epsilon. The result is epsilon. That's fine. The language will contain epsilon. Okay. Next, if I write W is A, other W can't put a B. But here you can put B. If W1 I can write A, if I write A, W2 I can put anything. Okay, no restriction. But here it has to be A. You got W. Suppose if I put a B, then other will be B, so you'll get double B. In case if W I put 2 length, let's say double E, then other W should be 2 length, double E. See that what is happening? And if first W I put AB, then second W should be AB. The result is AB AB. Okay. So you try to understand what's happening here. There is always dependency, right? You see that these two symbols are depending on each other. How do they depend? See, I'm just saying W, W. I'm just taking a bigger string A, B, B, A. If this is W, other W has to be same, copy it. Double A, double B, A. How do they depend? This A is definitely same as this A. And this A is definitely same as this A. And similarly this B here, and this B is here, and this A is here, right? So there is a dependency in both a W, and this dependency is not just for some time, it's going to be till infinite. W could be anything from A comma B whole star, but whatever the W you take, the same thing will repeat in the string. Okay, this is dependency till infinite over more than one symbol you have. The language is regular. I hope you understood why we have a dependency. But here what's happening, W1 W2, when you have it, see, whenever W1 is epsilon, W2 could be anything. Here only you got A plus B whole star, forget about all other things. When W1 is A, right, whatever you wanted, this is already covered here, right? This is already covered here. A epsilon, A, B, whatever it is, all the strings, right? All the strings already covered here when you concatenate W1 and W2. So this is a very important difference between WW and W1 W2. Okay. In case if you want to variate this problem? Yes, you can do it. A plus B whole plus. In that case, only epsilon will not be there, but whole concept will be same. Still, it is not regular, even you write whole plus. When will be this language regular? When you limit the length of the W. Suppose length of the W I kept less than 100. If you keep this less than 100, that will be also less than 100. So overall, this will be finite length, and of course, the number of strings will be finite when you put the length of the W restriction. Okay. But what is the difference between WW and W'? When you write WW, right, there is no other symbol apart from A's and B's, right? But when you write W', okay, there is someone, there in between two strings. Of course, the two strings are also same. Example, suppose I write ABB here, another string directly will get ABB, but here ABB ABB. Still, you will have dependency. That dependency you can't eliminate now because of right? Still, the dependency also is here. You can't eliminate. In either case, you have a dependency. Whether you have or not, the string has dependency, and the dependency will maintain till infinite, as the W length is not restricted. So it is not regular. Oh, sometimes I do mistakes. That's why I'm going back. Okay, this was not regular. I already explained clearly there is a dependency. That's why it's not regular. Okay, so please correct it. This was a non-regular. Okay, I was keep on saying all languages are regular. So in the flow, I just made it is regular. But WW such that W belongs to A comma B whole star is not regular. But W1, W2 was regular. Okay, I'm just cross checking it. Am I doing any mistakes? Fine, non-regular. Okay, so in this process, WW, W', both are non-regular. Both are non-regular, where W has no restriction on length. In case if you put a restriction on length like W belongs to A comma B whole star, in either case, right? These two are non-regular, we know it. In case if you want to make regular, what do? Additionally, you put just something like length of W is less than 100 or 10. Here also length of W less than 100, then these two will become regular. Okay. Now this time, as I'm putting the length restriction, these two are going to be regular. Okay, if you put the restriction over the length of the W, if you don't have these two conditions, these two conditions, these languages are already non-regular. Fine. These are the very special cases of the previous two forms. Okay, that's what I'm talking about. The length is less than or equal 100. So the language is going to be finite language. Why? Because you just write the strings, you'll understand. When you put W is epsilon, you will get only before after you will have epsilon. You don't get more than one length. And if you put W is A, then A, and W is B, B. How long you write? The maximum W length will be 100. See here, maximum you will have up to, you can say 100 length, and this total 200 and 201 length. The same form you will be having up to 201 length, But form should be maintained. It's not every string, right? All the strings which are in the form of W'. Fine. Is there any dependency? Yes, you have a dependency, but it's coming up to finite time, up to finite number of strings only. That's okay. We should have a dependency till infinite, then only it's not possible. But this language is finite, right? The whole language is again a finite set. Answer is regular. Okay, now already we know W1, W2 is regular. What is this W1 W2? If you remembered W1, W2, where W1, W2 both are A plus B whole star. Always remember what is here. This will decide the language. Okay, Based on this condition, I can make this language regular or non-regular sometimes. So don't just remember this W1 hash W2 W1 W2. What is this W1 condition? Where it depends? It's depending on belongs to A plus B whole star. Okay. W1 is any and no comparison with W2. That's why I can write A plus B whole star. Again, you may get it out, sir, why this W hash W is non-regular? Because you can't write here A plus B whole star. If you do this, it's wrong. Why? It's wrong. You can't put here W, whatever you have, the same thing should come here. When you write this two independently, you're saying that I can write anything here, anything. If I write A here, I can write B here, as I don't have any dependency at all. But in this form, you have some dependency. That's why this dependency cannot be eliminated. Hence, it was non-regular. Now, W1 hash W2. See, before hash, after hash, any sequence is there, right? It's already regular expression. You can design a finite automata for this. Till hash, you read everything. After hash, you can read everything. But go final after hash only. Okay? Something like before hash, A comma B. Once hash comes, go somewhere to the final and read anything. That's enough, right? If you want dead state, that after this, you should not have hash. After this final state, you can't have second hash, right? So you can have dead state for that. So it's a non-deterministic motion to accept this language. It is regular. It is regular. Okay. Can you think about, and it is one of the important concept here, length of W1 is equal to length of W2. Looks like there is a dependency, but the dependency will it have all the time when you form a language or when you write the strings of the language? Okay, let's think about what is happening when you say W1, W2, and here the lengths are equal. The condition must be lengths are equal. When the lengths are equal, both should be 0 or both should be 1, both should be 2, both should be 3, and so on, right? So you should look at that. Lengths only equal, not the strings. Both are right. So be careful. If suppose I am taking length 1, then if I take A as a W1, then W2 can be B. Length should be equal, string may or may not. So epsilon is 0 length, only one option you have epsilon. But when I take W1 is A, W2 can be either A or it can be B. So look at the strings I'm writing here. Okay. If I take W is B, W1 is B, W2 can be A or W2 can be B, and so on. What's happening here? See, here you get epsilon, here you get AA, here you get AB, here you get BA, here you get BB. Forget about W1, W2. Look at your language now. Your language will have epsilon and all the two lengths. Then after that, whatever you write next, 2 length, you will get all 4 lengths. All 4 lengths you will get. Okay. Here when I write double E, then other W2, the W2 can be any 2 length. No need to be double E. So I can have double E, I can have AB, I can have BA, I can have BB. So similarly, when you keep on writing for every W1 possibility, if you write all the W2s, you will get all 4 lengths here. So next, all 4 lengths and all 6 lengths and so on. What did you get from here? See, 0, 0, you got 0 length, 1, 1, right? You're talking about W1, W2, you get 2 length here, 2.2, you will get 4 length, and 3 followed by 3 length, you will get 6 length. And what do you get when you are talking about W1 dot W2? You get all even length strings. So this one is nothing but just all even length strings. Somebody can write very easily such W such that W belongs to A comma B whole star, length of W is even. Oh, they did not do that. They did not write that. They have formed the other way. to specify the same meaning. Okay, regular expression, if you want, write a plus b whole square and whole star. It is regular. You already designed DFA for this with the two states. Even length strings will take just two states to accept. Okay, to understand how you get the set of all even length strings, set of all even length strings, set of all even length strings. And where is the difference? The difference is, I'll show that somebody written W1, W2 where both are belongs to a comma b whole star. If I write W1 is equal to W2, which is exactly same as WW form. Do you believe that these two are exactly same? Same. Both are non-regular, you know that. Both are non-regular. Okay. But what we have done here, small change, rather than saying the W1 is same as W2, we have written W1 length is same as W2 length. This one is going to give you set of all even length strings. Over a comma b. Even though this is even length, but not all even length. These are only some even length. That's why you cannot design a DFA for this, as you have a dependency between the symbols of the string. Okay, it's the main difference, and these two are actually same. Instead of writing set of all even length strings, you have formed using W1 and W2. Okay, next one. Very interesting. Please take the time again. Now we are changing to over one symbol. I told you over one symbol we look at the arithmetic progression. We don't look at dependency. Right? Earlier we was using dependency word when you have more symbols in the language. When you have only one symbol in the alphabet, then definitely you should look at whether that forms arithmetic progression or not. WW such that W belongs to A star. You know, if you have only W, this would be very different, right? This is also one of the problem. This language is nothing but just in expressions you can represent as A star. Every W who is in A star means A star only, right? And that A star can be represented as a power n such that n greater than or equal to 0. Okay, now how this is different from given language? In given language you have L is equal to WW, where W belongs to A star. Here WW, don't put A star, A star. Remember that? A star, if you do that, it will become A star, and that's completely different from what I have written, here. So be careful. If I have W1, W2, where W1 comma W2 belongs to A star, you may write A star followed by A star. Don't put A star now. So here there is a dependency. If you write epsilon, epsilon, and then AA, you should do the same thing, right? If I keep W is A square, then other W is also A square, and so on. If you simplify it, epsilon, epsilon is epsilon, that's A power 0, right? A power 1, that's A square. A power 1, A power 1. A power 2, A power 2, that means total 4 A's you have. 3 A's followed by 3 A's, it will be 6 A's, and so on. What did you observe? 0 A's, 2 A's, 4 A's, 6 A's, and then 8 A's, 10 A's, and so on, which will be even number of A's. Somebody can say that A power 2n such that n greater than or equal to 0. This is the main difference between these two languages. This language also forms arithmetic progression, this language too. And what is arithmetic progression? You see here, in this language, first you have A power 0, that's epsilon, then A power 1, A power 2, A power 3, and so on. If we look at the common distance, Here epsilon to a, you just need to concatenate a, 1a, and a to a square, just concatenate 1a. Here concatenate one more a. So a is the distance between every two strings, every two consecutive strings. So one length is the common distance. So 1a is the distance here between every two consecutive strings. Here, if you look at the distance epsilon a square, you require 2 a's to get the next string. Here 2 length, 2 a's. After a power 2, you just concatenate 2 a's, you will get a power 4. Similarly, concatenate 2 a's, you will get a power 6. And here 2 a's is the distance. Okay, if you are talking about the lengths of the strings, lengths 0, 2, 4, 6, these are the lengths, and here the distance is 2, here distance is 2, plus 2 plus 2 plus 2, you'll get the next string in the sequence. So here you are talking about the lengths of the strings, the 2 is the distance. If we're talking about the strings of the language, the AA is the common distance between them, and that is the reason you are having the AP formation here. So when the language is forming AP, then absolutely this is going to be regular. This language is same as AA whole star. A power 2n is nothing but AA whole star, so which is nothing but even number of ways, so regular. You require 2 states. In case you are designing DFA, you require just 2 states. I hope you got a clarity. Though this one is having the 1a is the distance. If you are talking about the length of the string, the 1 is the distance between every two consecutive strings, and here the 2 is the distance. So these two languages are forming AP. So some of the languages I'm talking about now, like A star, or I can say A power n, AA whole star, even AAA whole star. A star, if you want to write a language, that's you write A power n. Here AA whole star, if you want to write a language form, it's A power 2n. This one, if you want to write in a set form or language form, use A power 3n. So all these problems are going to form arithmetic progression. Okay, so all these languages are regular as they are over one symbol, they forms AP, so they are regular. Fine. Any doubt? Great. WAW, such that W belongs to A star. Oh, definitely this problem is different from the previous one, but having a similarity, there you have 2 W's, here also you have 2 W's. Language absolutely different. Okay, now what are the strings you will get? You try to form the strings of the language. So what are the strings you will get? Just write, if I write epsilon, then other W is epsilon, because A power 0 nothing but epsilon. If you write A power 1, and remember, when you have W belongs to A star, no confusion, W belongs to epsilon, A, AA, AAA, and so on. That is the meaning, right? So just try to pull one string from this A star at a time, okay, in a sequence. Now after epsilon, I'll just put A, then you will have it 3 A's. Okay, so look at here, and next A square, next A power 3, and so on you will have. So what do you get? This one is just A, this one is A power 3, this one is A power 5, this one is A power 7, and observe, what do you have? What do you have? Odd number of A's. See that 1A, 3A, 5A, 7A, and so on. This is nothing but odd number of A's. How do you mention odd number of A's? The language is nothing but here. You can write as a language L is equal to A power 2n plus 1, such that n greater than or equal to 0. If you want to write an expression, just write 1A followed by AA whole star. You already know how to represent odd number of A's. In case if you want to keep A at the end of this even concept, just move the A to the last. That's also fine. So this is nothing but A followed by AA whole star. Odd number of A's. You already know these 2 states enough to represent odd number of A's using DFA. So it is regular language. It is regular language. Now it's very simple that if anybody is asking about, let's say 3 W's in a sequence, W belongs to A star. Now what do you conclude from this? See, first you put epsilon, 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 you get epsilon. Next, when you put a, right? When you put w is a, all are a's, so you will get a power 3. If you put w is a square, a square, a square, a square, you will get a power 6. If you put a power 3, a power 3, a power 3, a power 3, you will get a power 9. So what did you get here? You will get 3a whole star. That's nothing but multiple of 3a's, multiple of 3's. Okay, multiple of 3a's. Now you got this concept a power 3n. So here you require 3 states to design a DFA. And this language is also regular. Okay, over one symbol, they always form AP. They always form AP. But if you have more than one symbol, this language are going to be non-regular. So this condition is very, very important. Not only this form, but you also look at the condition. If it is rather than a star, if you see a comma b whole star, this language definitely would have been non-regular, right? Even it's same 3 consecutive w, I can make it non-regular if I change the symbols. Instead of having one symbol, if I keep 2 symbols in the alphabet, this language will become non-regular. So that's what I want to say. Look at the form and also read the conditions carefully to answer the language is regular or non-regular. Next. Oh, nice. W hash W. What is the difference between WW and W hash W? Here the symbols only one you have. Alphabet has only one symbol. So W belongs to A star. I am talking about same. W belongs to A star. Do not forget this at all. Okay, this is my main condition now. When you have here, you got this result like epsilon, epsilon, a square, and a power 3, and so on. This is generated as just even number of a's, right? So you just got W whole star when you try to conclude it, because this is given epsilon, a square, a power 4, a power 6, and so on, right? It looks like just even number of a's. Now what is here? Just write same epsilon hash epsilon and a hash a square hash a square, and a power 3 hash a power 3. But this is not going to give you even number of a's, because of the hash, it both will depend. The count, the result, the whole thing will give you as a power n hash a power n, which is definitely have the dependency. Before hash, if there are 100 a's, if you see 100 a's, then after hash also you should see 100 a's, same 100 a's. So this will create a dependency because of this additional symbol and. It's not over one symbol now. W is having one symbol, but language is having 2 symbols, hash and a. Here the sigma is gonna be a, but here sigma along with a you will have hash, but maybe you can say a union hash or simply a comma hash. Hash appear once, but a may appear any number of times. So look at the difference. It's over one symbol, the language is over one symbol, but this language is not over one symbol. Even though in both of them W is given over one symbol, but the language is not over one symbol. W is one symbol, is over one symbol, but language is not over one symbol. So it's a very important difference. Hence, you should not look at the arithmetic progression. Now you should look at, is it having any dependency? No, not having any dependency. Also, sometimes you may require to check, arithmetic progression, but main focus is that, do you have a dependency here? Yes. Then don't worry about AP. But here don't ever look at the dependency, as it is over one symbol. There you could have anything. Now you see dependency, right? There is a dependency in this position and this position somehow. Okay. After looking at the strings of the language, I see there is a dependency. So not regular. So not regular. Can you try now? Which is also similar to the previous one, but the condition is given something like length of W is less than or equal to 10. You know this problem is gonna happen like a power n hash a power n, because W belongs to what? A star, such that length of the W means this length only, right? A power n only. So n less than or equal to 10. It means the strings, if you see, first symbol is ash, first string is ash, next string is A ash A, and A power 2 ash A power 2. How long? Power A power 10 ash A power 10. Total how many strings are there? Right, 1 to 10, A power 1 to 10, you will have total 10 strings here, and additionally one string, 11 strings. So the size of the language is just 11. So it is a finite language. When it is a finite language, you don't worry about anything, just say it's regular. We don't check formation of AP, you don't check dependency, directly conclude it is regular because the language is finite. Yeah, very interesting. I told you already, right? But this is over more than one symbol. We know WW such that W belongs to A comma B whole star. There is a dependency. There is a dependency. Whatever you write here, the same thing should come here. Even though you have ash in between, still there is a dependency. So it is non-regular. We already know it. Now, if you have three W's, it's not over one symbol. Remember, over one symbol we know that was regular. But it's over more than one symbol and having dependency more than one time. So still you have a dependency. Still you have dependency. And here you write even 4W, 5W, doesn't matter. All will be having some kind of dependency. But more than one time happens, or 2 times, 3 times, it could happen. The same thing is repeating multiple times in different positions. Still you have dependency. All of them are simply not regular. All of them are non-regular. So choose non-regular. Is there any possibility of regular? Can you make this language as regular? Yes, you can make when you put the length of the W finite or length of W less than 10 or less than 100. You can make all this language or regular. So right now, these languages are having dependency till infinite. So we say they are non-regular. Fine. Next one. Oh, see, the form is same. What we have W belongs to A star. I already told if you have W such that W belongs to A star, this will give you simply A power n such that n greater than or equal to 0. If you have two W's, which will be even number of ways, we have solved in the previous slides, that is A power 2n you got here, because the common distance is going to be 2 if you are talking about the length. When you have 3 W's, you will have multiple of 3a's. Number of a's will be multiple of 3. That is A power 3n you will have. Now this time you have 4 W's. Then you can easily guess what's going to be. Multiple of 4. Right. They're all forming AP, A power n, 2n, 3n, 4n series. They will be having the AP formation. So they are regular. Okay. Fine. Let's move to the next one. Can you try now? Which is one of the important model for the GATE exam. Okay, how you should think about this kind of language? As you know, only what you do here is understanding the strings of the language. What is W and what is X? If you are trying to remember these things, you at the end you will forget everything. So I don't ever remember this what is WX. But when I'm trying to understand the language, automatically I will remember them. So here there is, kind of concept that you are going to use. First, understand the strings of the language. Later on, you will get to know what is WX. But those people who are trying to remember what is WX first, then you will forget about the concept. So now I'll focus on the concept rather than what is w comma x. Okay, as we are going to see a lot of variations here, w comma x belongs to a comma b whole star or a plus b whole star. Your focus is on many things here. I'll just show the points where you have to focus. Focus on this part, because this part is gonna be trick. And second is, what do you have here? This form. Two things you need to focus on. WWX. How many variables you have? Here symbols just a comma b. But how many variables you have? W and x. Who is repeated multiple times, x or w? W. Again. How many variables you have? W and x. And who is repeating multiple times, x or w? W. Where should be your focus? On w. Why? W is trying to create some kind of dependency. Can I eliminate that redundancy or dependency? So W is your focus. Try to rid of that. Try to get rid of that, because you don't need WW. You don't want such kind of dependency for regularity. So is there any other way to represent without WW? That is your target. Is there any other way without WW? X is not creating an issue because X is free. I know X. Instead of this, why don't you write it? WW such that a plus b whole star. W belongs to a comma b whole star. That would be fine. Where X is just one time up happening, you don't have any problem with that, right? So now this WW might create an issue. So is there any way that I can eliminate? Okay, I'm just writing. Is this equivalent to simply a plus b whole star? Can I write simply a plus b whole star? If I write, then what would be the reason? See here, I'm just trying to tell you what's happening. And this form, this whole form, I'm just putting what are the possibilities. You have w is equal to epsilon. When I put w is equal to epsilon, you will be having epsilon a plus b whole star. There's no doubt this is going to be a plus b whole star. Yes or no? So you got one case is a plus b whole star. But other case, I don't know what will happen, but w is equal, let's say a. Then what will happen? A followed by a. A followed by a followed by a plus b whole star. This is the second case. And similarly, you will write w is equal to b. You will get b a plus b whole star. And you know how many choices for the w? There are so many choices, right? Maybe double a b, bb, 3 length, 4 length, 5 length, any length might come. But at the end, these are the choices of w. If you want to get the result, you have to do the union, right? You're going to do the union. What do you get? A plus b whole star union double a followed by a plus b whole star union double b followed by a plus b whole star. You know, this is already having every string. And it is universal language. It is universal set. You know that. This is already covered here. It is already covered there. So result has to be what? A plus b whole star. I hope you are trying to understand. And there is another way to think about it. Directly you see here, when I put w is epsilon. When I put this is epsilon, then this simply x is enough to cover everything. X is everything, then remaining all, whatever you put w, a or b or whatever, then x is already covering. X is dominating whole set. The result will depend on x. If you can understand why I should depend on x, then your answer is over. But as you know, when we begin this kind of languages, we'll never know in the beginning that I should think about this way. I should think about that w should be, I should put epsilon or not. Because some languages we put epsilon, some language we can't put. Then you will confuse, sir, I'm not able to put epsilon there. There might be other way to prove it. That's what I'm talking about. If for this language, you can just answer within few seconds. That is by looking at this, okay, I have two variables here, one variable, that means W repeated here, X is free. So can I eliminate this WW? Somehow. That is, I can put epsilon there, so I can depend on X, but X is right or wrong. That's very important. Here X is everything, then only I am depending. If X is not having belongs to A comma B whole star, A comma B whole star, I may not dare that. Why I am depending on X? Because I know X is giving everything. If X is not giving everything, why should I depend on X? No. Right? You can't write equal to X. So that's very important. If X is not belongs to A comma B whole star, then you can't do that. Okay? So you should know when you should try to eliminate the WW, that when other variable is trying to provide you whole language, then you don't need a WW. That's what I'm proving. When you don't understand that way, this is best way to prove it. Okay? It's always best way. Take, minimum W and put it, take the next minimum and put it, and try to observe union of all this. Will you get any language that is already regular? If you don't understand the sequence union, and definitely there might be a dependency, observe it and say non-regular. But for this language, it is regular. Okay? Fine. Next. Please try this language. Only one difference. Previously it was what? Previously it was A comma B whole star. Now what is it? A comma B whole plus. Will it be same? Previously you are able to put W is epsilon, so you got X. But now can you do that? Can you put W is epsilon? No. That means now the language might have a dependency. You do not know that. Maybe X is everything, so you can put, if you want it, WW, the X can be what? A plus B whole plus. That's fine. Because I don't want to confuse with a lot of variables, so I'm trying to eliminate X. I'm trying to substitute X. Not eliminating, but substituting X. Now W I can't substitute right now because W has many choices, and one W, other W are having dependency. Now I need to focus on that. I'm going to focus on this. First I put W is epsilon. So what do you get? Right, directly I'm writing now. Epsilon epsilon followed by A plus B whole plus. So we'll get the language or the string form is going to be A plus B whole plus. Epsilon epsilon, right? This is a 1. And when I put W is equal to A, you will be having A followed by A plus B whole plus. I'm very sorry. This is what happens. Can you put epsilon here? Then why I'm writing it? So in the flow, previously we solved with epsilon. So be careful. Don't do this. This is when I'm able to do the mistake. So definitely you may do it in the process of substituting. So this never happens, right? What is the minimum W? A only. How can I put epsilon? If I can put epsilon, then already I could have got the answer, right? So here W belongs to A comma B whole plus. So minimum string is A here. So focus here. W belongs to A, B, and AA, AB, BA, BB, and so on. You don't have epsilon there, so you can't substitute it. Fine. So let me write here. That you will get A followed by A plus B whole plus. Next, W is B. One length I'm putting because as I can't put 0 length. B followed by A plus B whole plus. I'm trying to think about, is there any way that union of this can get common form? Okay. W is equal to AA. So what do you get? AA followed by AA followed by A plus B whole plus. And similarly, W is equal to AB. I put AB followed by A plus B whole plus. Similarly, I'll try to put W is equal to BA You get BA followed by BA followed by A plus B whole plus. And last one I'm just trying is W is equal BB. We'll have BB followed by BB followed by A plus B whole plus. You can think about the 3 length, 4 length and so on. Now what happens? Previously, there was the form in the beginning that if I do the union of all of them, you got the final answer as the first form I had. Okay, let me think about these two forms I take. Anyhow, this form cannot cover all of them, right? Because here double A is there, here AB is there, here double B is there. So let me take these two forms. I'll take this form as my answer. Let me take the union of these two. Will it cover all the strings which are having double A, which are starting with double A? Okay, double A I'm able to cover. So double B, which I'm able to cover double this one. But what about this AB? These two forms will not begin with AB here, right? AB. So definitely this is the new form you have. And this is another one which is starting with BA. Okay. Here, these two I take the union. Here I take this two union, but still it is not enough to cover the other W forms. If I take W3 length, then definitely see here AB is there, but this may not come. It could be possible that ABB might be the beginning, then that's not covered in both of them. Think about when W is ABB, because 3 length when I take it, here ABB followed by ABB followed by A plus B whole plus comes. That's not covered in this two. So in every W, if you take 1 length, 2 length, 3 length, every time you get a new form, because there is a dependency between these two and not enough to cover all the forms in the language. So it's even you do the union, the common language, you don't have the regular property. So it's having dependency all the time. What dependency you are seeing? The dependency is here itself. Let's say if this is W and W, this A should appear here and this B should appear here. So that makes not possible to eliminate in all the forms of the language. Within the language there are many forms, and each time you get a form and there is a dependency that may or may not be covered by others. Okay, hence it is not regular. So it's the main difference. When you had whole star, you were able to put epsilon, that is A plus B whole star, that it can cover everything. But when it is not having whole star, then W, when you put AA or minimum is AA or BB, that is not enough to cover all the forms. So always we have a shortcut, that is take the minimum form, minimum W. What is the minimum W here? Either A or B, right? When you take this two, it should cover the remaining all forms. If it is possible, then definitely this language is regular. When I take this two, if it's not possible to cover all the forms in the language which are taken by other W's, then we say it's non-regular. If it covers, it is regular. If they don't cover, non-regular. So always we focus on minimum W. So previously, when I take WX, when I take WX such that W comma X belongs to A comma B whole star, what happened here? Minimum W is epsilon. When I take that, it's equal to X, and X is equal to A plus B whole star. Everybody can believe in the world it will cover every other W that you take, because already universal language. But when I take minimum W here, this 2 comes. When I take this 2, it can't cover all other. You can see this can cover the 4 A's in the beginning, this can cover the 4 B's in the beginning, but this 2 cannot be covered by the minimum length that you have taken for the W. Okay, so this is one form that immediately you can conclude, when I put the minimum W here, is it possible to cover the whole language? If not, so there is some kind of dependency in the language over the between the symbols. Fine, let's go to the next problem. As you know, it is non-regular, it requires a practice, no doubt, and just compare the previous language and this language, and you will understand why this language is non-regular, why previous language is regular. Previously you try to do the union of all this, the first form was dominating all other, but here this form is not dominating. Even I combine this two, it's not dominating. Even I combine all this, it can't dominate others. So you know that the union of all these forms will still be non-regular. Okay. Yeah. Now again, we solve the same way. We don't change the direction, right? We solve the same way. W x w. And here w comma x belongs to a comma b whole star or a plus b whole star. Which form you have? W x is here everything. See again, is everything, right? So x is free and just putting what is x. Okay. Now you think about this one. Here only you can answer it. When I put minimum w, what is minimum w? Minimum w. What is it? Its minimum value of w or minimum string for the w is epsilon. You put epsilon. When I put epsilon here, what do you get here? Epsilon a plus b whole star epsilon. That is a plus b whole star. When you put minimum w, you got epsilon a plus b whole star epsilon, which is nothing but a plus b whole star. Stop here. Think about whole process. A plus b whole star union with all the forms of w. Will it be here this only? That means all other forms are useless. They are redundant. They are already covered by this. So you take any other w. You take any other w which is already covered by this form. Take any other w which is already covered, which is means the form already covered by the first w that you have taken. So that makes this language is regular. So in the exam, you don't need to write everything. Just take the minimum w. You got a plus b whole star. Now take the second minimum. The second minimum is already covered in the first minimum form. Then job is over. Okay. So that's first minimum, second minimum would be sufficient to check. So I'm going to check that. The second minimum I'm checking. What is second minimum here? Take second minimum w. That is w is equal to either a or b. Take that. If I take a, that is a followed by a plus b whole star a. Is it already covered here? Yes. Now take another one, b. b followed by a plus b whole star b. Is it already covered here? Yes, that's it. No need to go for 2 length, 3 length of w. Okay. So take the first w is epsilon. Then go for 1 length. If 1 length is already covered, 1 length forms are already covered. The 1 length forms means when you take w as 1 length, you got a form. That form is already covered in when you put w epsilon, you got a new form, right? This form already covering this one. So you say it is regular. The answer is very simple. It is just a plus b whole star. Believe it that it is a plus b whole star. Because when you do union of all this, this is dominating everything. Okay. Someone has to eliminate by putting epsilon here. Sometimes other than epsilon, you may get something else. But this kind of languages are very easy. So it is regular. So far, what did you understand? Okay, let me explain one more thing. When you have WWX, WXW or XWW, if you can put W comma X belongs to A comma B whole star, I'm talking about only whole star. Remember that is very important. I can eliminate them very easily by putting epsilon, By putting epsilon, all of them result will be X, so that answer will be A plus B whole star. All these forms, you will be having the same answer A plus B whole star. Okay. When you put the minimum W, that is epsilon, the X is enough to cover every string in the world, whether it is is present in other form or not. It's enough because in the language it is already present. That's why the X can dominate whole language. Fine. Okay. This is regular. Now let's move. Okay. WXW such that WX belongs to A comma B whole plus. Now what do? Whole star means you can put epsilon. But when you can't put epsilon, then you might see some difficulty. That difficulty you need to practice. Okay, what is it? Okay, W, I am going to do something here. W, X, W. I put X as it is so that I don't need to think about X many times. Okay. Great. Now, I told you one thing, that is, take the minimum W, compare with the second minimum. If the second minimum form is covered by the first minimum is your answer for whole language. Whole language is dominated by the first form. Okay. Now, in this we are going to work on. What do you put here? You take only two things. What is minimum W? That is, length of W is 1, right? So I'll just take that. What is the second minimum? The length of the W is 2. This is the first minimum and second minimum. Because first minimum you have two possibilities. W is either A or B. Here what do you have? Here W is, there are 4 choices. Or AB or BA or BB. That's the lengths we have to consider. Now with this, whatever the form you get, if this form can dominate all this, then answer is very simple. Let's try. What do you get? When I put A or B, what do you get here? You get A followed by A plus B whole plus A. When you put A, when you put B there, this is a one form, right? Plus means union. When you put B here, B followed by A plus B whole plus B. Okay, this might be your answer, you do not know it. This will be your answer in case if these two forms dominates all other forms. In case any form is missed here, that means that string cannot be covered by these two forms. So these two forms cannot be your answer overall. Okay. Assume this might cover all forms in the language. Maybe I am checking for 2 length, but indirectly, if 2 length is covered in 1 length, 3 length also will cover here somehow. So using transitive property somehow. Now I'll go for 2 length. I'll just write all the forms to check. One by one, I'll check immediately. If it is not covered, you can stop. No need to waste your time to write all the forms. Okay. So first I'll write double A. Double A. When I put double A here in place of W, what happens? A plus B whole plus another W is also double A. Is this form already covered here? Yes, because here starting and ending with A, and you could have at least one length in between, is already covering this one, right? It's not only just starting with A, it's starting with double A, ending with double A, and minimum 5 length is already covered here. Okay, so this is covered. So I'm just putting tick mark. Next, I'll go for AB. What is AB? AB followed by A plus B whole plus and again AB. Now, is this covered by these two forms? Okay, starting with A is there, but it's not ending with A. This starting with A, ending with A similar form, starting with B and ending with B form. Here starting with A, ending with B. So this is not covered. Let's stop it. You don't need to verify other two forms. And now you can conclude here, oh, this language has a dependency. The dependency cannot be eliminated. It's not actually, you can't eliminate the dependency because it's called as pure dependency. Okay. The repetition of WW cannot be eliminated. So it is not regular. Okay. It is not regular. You see that in both of this, in previous one also, when you had whole plus, you got a dependency. So not regular. Clear? This is how you can work for the exam point of view, which can be answered by practicing, within a minute you can answer this question. Okay? Let's move to the next one. You should not take much time to answer this question now. As you know, whole star is there. So what do? You put epsilon here, minimum. So you get X is answer, X is everything. Then you should believe it. This will dominate all other forms. So it is regular. That's all. It just take 5 seconds once you practice it, even not 5 seconds. Okay. Now XWW. When you see whole plus, don't answer, because you need to observe a lot of problems, then you can conclude it is regular or non-regular. First time when you are saying, you should do what I'm explaining. You should do substitution, take the minimum W and get the form, go to the second minimum of W and get the form, and look at, is that second form what you have taken is covered in the first form or not. Okay. XWW. So I'm writing here XWW. What is the condition you have? X and W having at least one length. What is this XWW? X is free, so I'll put it to avoid the confusion. Okay. Good. Now you need to form a language with the different forms. Here, I'm going to write one by one. What is the minimum W? That is length of W is 1. That is W is equal to A or B. What is the form you get for this language? That is A plus B whole plus A followed by A, or A plus B whole plus B followed by B. These two forms you will get. Okay, these two forms you will get. If these two forms, this or this, can cover all the forms, then this will be your answer. Okay. Now length of W is equal to, what are they? You know already. The W is equal to AA or AB or BA or BB. Let's try. Now put first WA, A plus B whole plus AA followed by AA. Is it covered any one of this minimum form? Yes, it's covering this one, right? So I'm just putting tick mark. Next, I'm going for AB. A is over. Now I'm going for AB. A plus B whole plus AB followed by AB. Is it covered here? Check. Oh, ending with double A or ending with double B. This is not ending with double A or double B. It's not covered. So stop here. No need to check other two and say, okay, this is not having regular form, so it is not regular. Just conclude it. If you have not seen this language before, definitely you should do this way so that you can conclude very quickly. If you are just thinking randomly, and you may go for right or wrong answer if you don't have a clarity on this language. Yeah. Now another form, you know that reverse of the W, right? Whatever you have here, suppose W is AB, then what is its reverse? It should be BA. And X, whatever you put, X is there. X means something from the A plus B whole star. The reverse of the W that you will see in the form while writing the string. But you know it's a whole star, right? I already told W power or W doesn't matter. When you have whole star, you see when you put minimum epsilon, so when you put this is epsilon, this will be also epsilon. It is equal to X, and that X is everything. So you should believe this. When you put the minimum W, take any other W which is already covered in X. So X union with, you write anything, AAX union, BBX union, and so on, the X will be your answer. Hence, it is also regular, as there is no dependency. Only somebody is writing WW power R doesn't mean that you have a dependency. Remember that. That can be covered by X in some other time. Okay. So most of the people have, some misassumption. Whenever they say it, doesn't matter X is there or not. Whenever they say it, it's not regular. Wrong. It could be regular based on the conditions that I take. I may take other variable, or I may put a restriction over the W. Getting my point? So all these situations can create regularity sometimes. Okay. So here, because of whole star, this can be eliminated by taking X. The X can cover whatever you want to do with the WW power R. I will say, sir, how this would happen? Suppose I'll take W is equal to AAB. Then X is equal, let's say, B. This is my combination, and look at what is happening. When I put there, when I put in the language, AAB, reverse is BAA, and what is X double B? Sir, how will you verify dependency? You are saying A plus B whole star, but is this covered in A plus B whole star? Absolutely. This I will cover in other way. I already taken some form that's already covering it. See, I already took this other way. Think about this way. Epsilon dot, whatever you do this, I will assume as X only. This is already covered. See that? Your assumption is different. The W is AAB, so that AAB, BAA, X is here, W power R, X. But I have already covered. When I took W is epsilon, W power R, epsilon, and X is everything. In my form, whatever you do it, it's already there. It's already there. Okay, that's what I'm saying, because this is also there in your language. That's what you should believe when you take the minimum W. If it's really covering it, so think about what I'm talking about, the minimum W, which is definitely going to cover in case the language is regular. If it is not a regular, this cannot guarantee. That's what we don't believe on the minimum W all the time. Minimum W only sometimes will give you answer, not all the time. When it is giving you answer as regular, you should believe it. But it's not giving a regular, then think about, is there any conditions that can make regular? Mostly not regular, but just think. Okay, in this case, it is regular. Now whole plus, again whole plus. Don't believe all the time it's non-regular. Sometimes it might give regular in case that X might be placed where it can give regular. Okay, right now we are just practicing. We will not look at who is regular, non-regular. We'll just try to prove it. Wx belongs to A comma B whole plus. Okay. X is free, so better to put to avoid confusion with many variables. Okay. Whole plus. We know what is W? A plus B whole plus. Okay, do not confuse with the notation. Sometimes I write A comma B whole plus or A plus B whole plus, both are same. Now I want to check, when I put a minimum W here, when I put minimum W, that's minimum W is either A or B. Will it cover every other form? If really covers, there's no confusion at all. You can believe this is your answer and you can say regular. Okay. A, its reverse is also A followed by A plus B whole plus. And another form here you will get, here only you will get B, its reverse is B. This or this. This or this. Okay, there are two forms here. Now take the second minimum, that is length of W is 2. The minimum W is length of W is 1. You can see here at least one length. So 1 is the minimum, 2 is the second minimum. And W is, you know, double A or AB or BA or BB. Let's take one by one and cross check. Put AA. So AA, its reverse is also AA followed by A plus B whole plus. Is it already covered here? Yes, you can see that. Starting with double A followed by plus 1 is already covered. It's a 5 length, right? It is also starting with double A. This is covered. Next, AB. AB, its reverse is BA followed by A plus B whole plus. Is it covered? Check here. Oh, starting with A, B, B, A. It's not that, right? This two only there. Starts with A or BB. So you go there and say it's not covered. Now you believe that this form which is taken when we substitute with the minimum W, it's not covering all other forms when we substitute other W's. So we say it is non-regular because there is a dependency between the symbols of W and W power R all the time. Fine. Conclusion is very important. If this is also covered, then we'll go for this one and then this one. Then finally we conclude. Okay. If all the four forms, other two forms I'm not writing because waste of time. In case if you want to write, you may write. All the four forms are covered in these two forms somehow, then we say it is regular. If you miss any one of them, then it's very easy to prove it is non-regular. Next, again, star is very easy. Star, right? Star, whenever you see it, just try to eliminate quickly. You see w comma x belongs to a comma b whole star. Before substituting, you can just think about it, put epsilon, or you may just write it w a plus b whole star and then w power r. No need to write, just look at and think about this way. When you put epsilon here, already you are getting right. When you put minimum w, you see that minimum w, what is that minimum w? Is epsilon. When you put epsilon here, you already got a plus b whole star. Epsilon followed by a plus b whole star followed by epsilon is same as a plus b whole star. You take whatever, without writing also you can see that, oh, this definitely should cover here because it is everything, right? No confusion, no need to write this. Already you got, it's clearly showing that I have everything. Then why do you want to check others, right? So this is a trivial property, so it is regular. So it is regular. Next. Oh, it is one of the really important questions so far. Why is that? See here, if you could haven't remembered that WWX, what else? WXW, XWW, or whatever it is, you know, WW power R X. In future, you may get XWW power R. All of them, when you have W comma X belongs to A comma B whole plus, these all are non-regular. But when you have an X in between W and W power R, when W comma X belongs to A comma A plus B whole plus, it will become regular. This is the main difference between these two. In all the forms, when you have a WW, X can be anywhere. But when you have a WW power R, X is not in the middle, X is not in between, then it will give you not regular. But why this will give you regular? And it was the PYQ many times, get PYQ, and now we will look at how to say it is regular. So understand what kind of property that we are looking at. We are looking at the property where X is standing in between W and W power R. But here X is standing between WW will not work. We'll see that property later on. But remember this, what's happening in all these languages. Okay, now we'll try to use the same approach. WX, W power R, which is free here, X. So better try to substitute X, as we don't have any problem with the W. W you can't substitute directly. So that is A plus B whole plus. Now W can be substituted, but substitute only with first minimum and second minimum. Then try to compare first minimum with second minimum. Okay, now here I'll just take the first minimum. What is the first minimum? Either A or B. What is the second minimum? Either AA or AB or BA or BB. What is the form you get? If that covers all forms that you see here, then this will be regular. That would be sufficient to check. I'll tell you why this happens. Okay, I'll tell you why this happens later. A or B. When I put A, what happens? A followed by A plus B whole plus. Reverse is A. Or you can write a plus, or you can write below, whatever it is. Or if the string is not here, it might be here when you take a B, because both are derived with the help of minimum W. These two forms you got with the help of A and B. And what are the forms you get here? Each form you just cross check, is it covered already or not? If it is already covered, then you are safe. Just start with AA. When I put AA, you have AA here and A plus B whole plus. Reverse is AA. Is it covered in only one of the form? See this, the whole form is already covered. Where it's covered? See, this one is already covered here. It's a subset. It's subset of this one because it is superset of this one. So this one is already covered there. Okay. Next, AB. When you put AB here, you can add anything in between W and W power R, and W power R is BA. Is it already covered somewhere? Starting with A and ending with A. Is there in between anything can come, at least one length. Okay, more than one length is there, right? This was already covered here, the same place. You can see there. In both of them, the starting and ending with A is there, and here it's demanding at least one length in between. Here you have more than one length, so definitely it is already covered by them. Next, this is also over. Next, BA. What is BA? BA here followed by A plus B whole plus BA reverse is AB. See here, starting with B, ending with B. Is it already covered here? Yes. Right. This form is demanding at least one length should be there in between, but here already more than one length. So definitely it was covered by A plus B whole plus. Next, BB. BB followed by A plus B whole plus BB reverse is also BB. Again, this is also having starting with B, ending with B. So it is also covered here. Now, do you believe all the forms which are derived with the help of the second minimum of W covered by all the forms which are taken or derived from the first minimum? Then you believe this has to be your answer. So the language what you are looking at here is equal to these two forms. They are regular expressions, obviously, or B followed by A plus B whole plus followed by B, and it's your answer. It's a regular expression, right? There's no doubt about this form. It is regular. It is regular. Fine. What behavior is here? What behavior you are seeing here? Okay. If you look at this, I'm just trying to tell you whatever it is that you have taken, it might be covering these strings. Okay. It might be covering these strings. This might be when you take length of W is what? 1. Remaining what you take, maybe it's like this. This is the length of W is equal to, maybe, remaining length of W is equal to, you don't know, right? They could have any form, you don't know, but they never cross the length of W is, okay, 1. See, this length of W is 1, this form you got, which is superset of all of them. When you take length of W is equal to 3, they might be here, you don't know, right? And you might be so many forms. 2 means here, sorry, I'm just saying it here, don't say 2, better to say, okay, let me write here. I'm sorry, 2 is actually 1 only, right? That not that many, but let me write. This might be 2, but here in this you have lot, like this portion is when you take W is equal to WA. This portion may be W is equal to AB. That's also 2 length, obviously. It might be BA and so on. I'm not saying exactly, just I'm saying why this property is preserving here somehow. W is equal to BB, something like that. So just assume that a 2 length is covered here, all the forms, and 3 length is somewhere in between, or maybe, which might be out, but sometimes the one of the case you will get length of the W is equal to 3 here. And the one possibility is that when I take the minimum W, which is covering all the forms and which is equal to language only, this form, this bigger box is equal to language, because when I do this, all the boxes union, you will get the bigger box only, because that bigger box is a superset of all the forms. That's why, this is only the one case. Other case, this 2, 3, 4 can overlap. Here there's a beautiful relationship. 4, all the forms are there in 3 forms. All the 3 length forms are there in 2 length when you take W, and similarly that all the 2 length forms are in 1 length. Somehow this happened. The one case I am talking about. So here such relation preserved. When you take 3 length, all the 3 lengths might be covered in 2 length, or in other case all the 3 length might be covered in 1 length. There could be a transfer relation, or there could be everybody might relate with only first one. It's okay. So that's the internal meaning of why we are approaching this, why we need to verify only the first minimum of W and second minimum of W, because this could give the quick answer in the exam. In the exam, you can't sit and think about every W, right, which will waste a lot of time. When you have a practice, just practice on what do you require to answer the question. Okay, that is the reason this problem is important when you compare with other forms. Okay, there is another one, XWW for R. I think you can directly answer it now. When you put the minimum W, you got X. X is an answer, X is everything, so you believe it. You don't need to worry about what the second minimum of W. Okay, it's regular. Now here we will verify. Here I have whole plus. Oh, is there any possibility of regular? Because we got WX W power R. In this case, the first minimum of W is covering the second minimum of W, right? Now we will check the same thing. When we take X W W power R, of course the condition you should remember. X is free, so better to put that. Okay, this form we have. And is this form, of course, W should be A plus B whole plus, A comma B whole plus. So be careful. What is the minimum W have? That is either A or B. What is the second minimum? W is either double A, AB or BA, BB. What form you get here in the first minimum? That is A plus B whole plus, W is A, then reverse is also A, or this is the first form I got. Second form for the minimum, first minimum, the A plus B whole plus, first W is B and reverse of that W is also B. We got this one. If really these two forms are covering all these four forms, then you are going to say regular, otherwise not regular. Take when you have W, what do you have? A plus B whole plus double A double E. Double A, its reverse is also double A. Is it covered? Yes, it's covered here. Okay, it's covered already. AB. Now just take the same thing. A plus B whole plus AB. Its reverse is what? BA. Is it covered in these two forms somewhere? No. So this is missing. So I'll stop here. When this is not covered anywhere, then why do you want to go for checking others? Not required at all. Stop here and say this has dependency. You cannot write without a dependency. So it is regular. It is, sorry, it is not regular. It is not regular. Okay. You can't believe this is an answer. If you write only this is an answer, you will miss these strings from here, right? Ending with ABBA is not covered here. You will miss a lot of strings. You can't write the subset of the language. I'm asking about the language. You can't conclude with the subset of the language. Fine. Oh, how big it is doesn't matter. How big it is doesn't matter. Now you can easily answer. See, X is here, sitting here. That would be sufficient. What do you want? Can I answer which is equal to X? But don't write X when you have whole plus. You should believe when you have A plus B whole plus, X can't be answer. Why? You can't put W as epsilon, right? Here I put epsilon in all of them, so I can get X. When I put epsilon everywhere, when I got an X, X is everything. When X is everything, I'm not writing on my own. I'm just saying that in my language, I have all the strings from A plus B whole star. Then why are you looking at? See, in one condition, you got whole universe. Then why do you want second condition when you're doing the union with that one? Okay. So this is what you have. So I'm trying to look at, in my language, every string present or not. Look at that. In my language, every string is present when I look at only on X. In that case, you got A plus B whole star, say regular. Okay. Yeah. Look at some scenarios where you can say the language is regular without worrying much. Previously, When you have whole plus, did I say that is not regular? Is this not regular or not? Okay, let me write a comma b or a plus b, doesn't matter, right? A plus b whole plus. Is it not regular or not? Not only this, how many things you have written? W x w, or what else? X w w, w power or x. And don't put x in the middle. That's only the language which you see the different. When I compare with wx w power r, condition is same. This is only regular, right? Just now we have seen in the previous slides. And this all are not regular. We know it. But I can make these languages as regular by restricting something. Here, the dependency is happening because of ww or ww power r. When you put the length of the w is finite, up to 9 length only comes the w, then that 9 length, up to 9 length, you can take care of it. So when you have 10, just put 1 or 2, you can easily understand. So 10 is a very big number, so you may not come to the conclusion very quickly. So I'll just change the 10 to, let's say, 2. Instead of 10, I take 2. I'll just tell why this language is regular. Okay. So these were the previous examples. Now I'm going for instead of this language, I'll just take another language just to conclude very quickly. That is w comma x belongs to a comma b whole plus. I'll just change length of w is less than 2, so that I can come very quick. I can come up with a very quick answer. When length of w is less than 2, what are the two cases we have? 0 or 1. 0 or 1. Here I have length of w is 0 or 1. That's it, right? Now here you put it. Two cases only, right? 0 case, x you will get an answer. So when you put length of w is 0, that means w is epsilon. W is epsilon. Epsilon, epsilon, x. What is x? X is a plus b whole plus. That's it, you have got this one. Clear this point? Clear? And you should believe it. When you take less than 10, epsilon was there already. You got the answer already, right? Whole plus. Now take whatever now. You take length of w is 1. Doesn't matter which should be covered here. That could be possibly ax or bbx. That means ax is a plus b whole plus, or bbx means bb a plus b whole plus. Both the forms, this form and this form, already covered here. So what should be the answer? This is equal to a plus b whole plus. If you could have understood, when you take less than 10, already here 0 was there, length of w 0 was there, so you can put epsilon here. You can depend on x directly. Okay, so use our technique or take the smaller number to think quickly. The answer is same. But when you put length of w is unknown, arbitrary, then this problem is going to be difficult to prove. Is that clear? Oh, I'm sorry. What I did the mistake is, sometimes even I do the mistake, right? So here already 0 is not there because of a plus b whole plus. Very sorry. No, the condition is whole plus. So let's change the question, right? Why do you want? Instead of 0, what do you have now? 1. Now you don't have this case at all. And I'm very sorry, epsilon was not there. I was not able to say it, but still it's okay. What happens? Nothing, right? Now you got this form. Because I can't put a 0 as the condition is here a comma b whole plus, right? Even though I have written, I have not taken it properly. So now this is your conclusion. When I take length of w is less than 2, length of w is less than 2, what happens here? You can take only length of w is equal to 1. You got this form. Do you believe this is regular or not? Yes. When somebody is saying length of w is equal to less than 10, you should start from this. Length of w is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Till this form, you write all the regular expressions and combine them, you will get another regular expression. That's it. You're not going for infinite forms, right? So you will have few forms only. So when you do the union of all those forms, you will get a one regular expression. That's why it is regular. So what I'm trying to conclude here, when you have the restriction on W, which is the finite length, because you can't go for beyond this 9 length. So when you have the restriction on the W with the finite length, then the language will become regular. Let me give you some examples now. Whether it is WWX or what else, WXW or XWW, even WW power R X, even including, already we know WXW power R was regular when it was whole plus. All these things you can make regular, including even it was regular, still it will become regular. W comma X belongs to A comma B whole plus, where you are putting length of W is equal to or less than or equal to, all are same. Even less than 10, all are same. So all these languages will become regular. Regular expression might be different. Only for the exam point of view, here if they are asking identify regular, non-regular, just you need to conclude it. Okay. Okay, don't worry about this length of W is equal to 0, which is not there at all. I have taken a mistake. Fine. So now you got a conclusion that when you have a restriction on the W to the finite length, then this language will become regular. And here I have just shown for less than 2, but if it is less than 10, till 9 length you take and write all the forms. This I have shown only for the 1, right? Similarly for 2, for 3, you write all the regular expressions, combine them to get the answer. Okay. Move on. So many languages, right? Now I don't need to prove it. I just shown it less than 10, right? Now restriction on the W up to finite length. Okay, that's fine. You will get a definitely regular expression. Answer is regular. Don't say finite language. When do you say finite language? If really you see length of W less than 10, length of X also less than 10, the language will become finite. Okay, you should know when do you say finite language. Even though length of W is less than 10, but X is not restricted, still it is infinite language, but no dependency. You don't have a dependency. But when you have the condition on both the W and X, then this will have the finite length. The whole form will have a finite length. Hence, not only just finite length, I'm talking about number of strings will become finite. Number of strings will become finite in the language. So in that case, the language will become finite language. But right now, the language is still infinite, but you don't have the dependency till infinite. Very simple again. Can I conclude directly regular? So now no explanation. Just answer it. Again, regular. I just told the same concept will come out here. Oh, whole star. Previously it was everything you should read carefully. Whole plus whole star. But still, answer is same. Right. Still it is regular. Even though length of the W is restricted, it's equal to, but this time language is equal to A plus B whole star instead of the previous answer, right? Now this time A plus B whole plus. So answer it carefully. Do you want to know exactly what is the language for each one? You can check. What is the length of W is equal to 1 here, right? When you put a 1 here, what happens? You will have AX or BBX. Similarly, you should write when the length of the W is 2, you'll have AA, its reverse, and AB, X you take care of it by substituting with A plus B whole plus. AB, its reverse is BA, and some of them you can ignore it. Later on I will tell you that. And then BA, its reverse is AB, and BB, its reverse is BB, and up to how long? Till you should take length of W is 9. that W is 9, you put in the form W power R X till that time. But here, so this one is already covered here, so you can ignore it. And whichever is, this one is already covered here, you can ignore it. But you will get few forms, and that you combine all of them together, you will get a regular expression. Always it need not be one simple form. Like in the previous question, sorry, this one, you got one answer. Because W you can put epsilon. When you put epsilon, X is giving everything. But this cannot be expected from every language. Okay, try that. Same, right? It's regular here because of whole star. You will be having A plus B whole star is an answer. Because W and W power R is less than 10, so I can put epsilon. I can say that X is my answer. X is my answer. Oh, this is different from the previous one. X, W, W power R, Y, such that W X Y belongs to A plus B whole plus. Now, how many are free here? X and Y. I just take that substitution directly. X and Y have no dependency, right? I'll just take it. Now you focus on this form only. Now you have two cases, as I said already. Take W minimum length. What is that? A or B? Second minimum, you know that 2 length. I had to cross check. Is that everybody covered? When you take A, what happens here? A plus B whole plus A followed by A plus B whole plus. This is one form. What is second form? A plus B whole plus. When you put W is B, then reverse is also B followed by Y is everything except epsilon. So this is the form you got finally when you put the minimum W. Now when you put the second minimum, if every form is whatever you get, is it covered by this first form, whatever you have covered with the minimum W, then it is regular. If not covered, any one of the form that you take here or derive here, then the language is non-regular. So let's check what happens. Double A, when I take here, the form is A plus B whole plus double A, I write here, and reverse of the W, reverse of double A is also double A, and Y is already we know A plus B whole plus. Is it covered? Let's check. Is it covered somewhere? This is 4 length minimum containing double A. This also contains double A, right? Either you can take this double A or this double A, or there are so many 2 consecutive A's here. So somehow here you can see this form is already covered here. This is the subset of that one. When I have this all strings which are generated by this form covered by this form, and it is also in the language, this is also in the language, this dominates this one, so it has to be superset, and that should be the final, right? Next, when you take AB, so when you write AB here, reverse is BA. A plus B whole plus AB, its reverse is BA. Its reverse is BA. Now you tell me, is this covered any one of the form? Is this covered by any one of the form? You see, observe, here double B is here, correct? And before, after at least one length. Before more than one length, after more than one length, it's covered here. Okay, look at what's happening. So take BA. A plus B whole plus BA, its reverse is AB. Now, is it covered by someone? See, double A. Before at least one length, after at least one length. Oh, more than one length, after also more than one length. So definitely this will be covered here. Now last one, double B. A plus B whole plus double B, reverse also double B followed by Y, that is A plus B whole plus. Is it covered? Yes. The double B you can assume, there are so many two consecutive bits. You can assume anything is the double B here, any sequence, either this double B or this one, and remaining is covered by the before and after what you have there. So it's covered by here. Now look at all the forms derived when you take the second minimum are covered by all the forms which are derived from the first minimum. That's why this language is regular. And what is the answer for this? These two forms. So this can be written as a plus b whole plus double e whole plus this form a plus b whole plus double b a plus b whole plus. These two forms. In the exam, they might, take a plus b left side common, a plus b right side common. That's, they may confuse many ways, but you should know this is the best form that you can answer in the beginning. Once you know the answer, in both the forms a plus b whole plus common is there. You can take left side common. In both the forms a plus b is their right side, a plus b whole plus is their right side. You can take the common right side. Okay, that can be written in case if you want to know a plus b whole plus, you will left with like double a or double b a plus. It's a very easy to answer it, right? Apply a plus b whole plus from left side once and a plus b whole plus apply from right side, you will see the same answer that you see above. So it is regular. And one of the important the language which looks like there is a w power r, but still it will form a regularity. It will form a regular language. The reason is the x and y are actually helping this w power r to cover the dependency into non-dependency. What about this wx wy? So can you do it on your own? Yes. Okay, I'll give the homework later, but let me explain this. Okay. wx wy. What is everything is whole plus, right? Just you remember it. wx y. If it is not whole plus, if it is whole star, then answer could have been regular directly without checking many things. Now you have to check, as you can't conclude very quickly. Now based on the practice you will answer very quickly. Okay. Now xy I am trying to put, as I don't want them many times you look at them and we will confuse, right? So let it substitute directly them. They are free from comparison and they are independent. Now here I'm going to put the minimum w. What is the minimum w here? Epsilon or a or b? Sorry, epsilon or one length, 0 or one length. So I'll put a or b. Second minimum is, already, it's 2 length. What do you do now? You put a here. What happens? A followed by a plus b whole plus, and put another a here because the w is also a, right? First w is a, so second w is also a. This is one form. What is another form? When you put w is b, both are having one length in the w. Okay, I assume this might be your answer in case if this covers all these forms. When you put w with second length, 2 length, put w here, here and here. So you will get first form a plus b, sorry, first is w followed by a plus b whole plus, w followed by a plus b whole plus. Is it covered here? Just look at carefully. Here you have a. So you can take this a and another a. Where do you take? You can't take this a is another a. You can take this a or this a is your choice. So I'm taking this a, and remaining in between these two a's, a plus b whole plus already there. this was covering starting with a and followed by at least one length, and after this a you have minimum one length is enough, but here minimum two length. This is already covered, right? So somehow this is covered here. Next, AB followed by a plus b whole plus followed by AB followed by a plus b whole plus. Is it covered? Any one of the form here, starting with a, just you can go for the only this one, right? You can't go here. So starting with a, so let me assume this is a, and this a, is it there somewhere in the middle? Yes, you have it. That means this, whatever the portion you have, a plus b whole plus can cover whatever you have that a plus b whole plus can generate. So this is also covered here. I hope you are able to understand. Next, when you put BA followed by a plus b whole plus BA followed by a plus b whole plus. Is this covered by the second this second form in the box, that is B? And where is another B that is there in between 2a plus b whole plus? Here. And whatever there in between two B's, which can be covered by a plus b whole plus, after B whatever you see, a plus b whole plus can generate because it's a superset of that form. Double B is the last one, right? This 1, 2, 3 covered. Now double B, a plus b whole plus double B followed by a plus b whole plus. This obviously it will cover, right? You need two B's. There's a one B and somewhere you can take any one of them. Second B, and remaining portions can be generated by the whatever you have. So it is also covered. All the four forms are covered by these two forms. So answer is this one. Answer is this one. So this language is also regular. Okay. Very simple. Now, how difficult the form is doesn't matter. You can use a similar concept to prove regular or non-regular. So you can treat as a shortcut which will solve, if you practice it, just it takes 1 minute max, I guess. I'm explaining slowly, that's why it will take 3 to 5 minutes sometimes, but really within a minute you can apply this technique to conclude languages regular or non-regular. Yeah, please take it as homework. What is the change? Previous question was wx wy. Now I have given x w y w. Both languages are regular, no doubt, but this is your homework and try to prove it. Why it is regular and what is the answer? What expression you can give an answer? Previous one, this expression, right? This language is nothing but this or this. Similarly, you should know what is an expression for this language. Okay, this both the forms are regular. It is also regular. I'm giving an answer, but take it as homework, and below this video in the comment section write the answer for this. I am giving it is regular, but what is the expression you will get when you put the minimum W? And that expression you can give in the below comment for this language. Write the language name, write the language, and below that you give a expression. So you may say like x w y w. This is a language where all of them belongs to a plus b whole plus. You can put that in the comment section. Okay, let's think about. Now you have more than one symbol, that is here 3 symbols we have. How many? See, you know, a power n, b power n, which is already non-regular. Now you are talking about a power n, b power n, c power n, where n has no restriction, right? You are not putting the limit on n. If you put it n less than 100, then this could have been finite language. Now it is not a finite language. It is infinite language, no doubt. And there are 3 symbols are depending on each other. How many A's? Let's say 100 A's, then 100 B's, 100 C's should come always, right? So here number of A's equal to number of B's equal to number of C's in the string which is having A's followed by B's followed by C's. It is not regular. It is not regular. So all these languages are not regular. Not only this, I told many times like a power n, b power 2n. I will write many things here. A power n, b power 2n, c power 3n. And not only this, a power n, b power n plus 1, c power n plus 2. where n has no restriction, then all these languages are not regular. All these languages are non-regular. You can form your own way in case you really wanted to write a different kinds of languages. Keep on doing it yourself, like a power n, b power n plus 5, something like that. All these things definitely going to be non-regular. What about, I just told, right, a power n, b power 2n, what is it? Not regular. When will be regular? Yes, it is possible sometimes when you have this one. In case I put a restriction n less than 10, over, language will become finite, then this will be regular. But it is not finite, right? It is infinite. This language is infinite and dependency is there, so that's why it is non-regular. Okay, look at the difference between these two languages. One will be non-regular when there is a dependency between the symbols. One will be regular even though looks like there is a dependency, but that's coming up to finite time, we don't call it as a dependency. Fine. It's same, a power 2n, b power 2n is same as what you have seen, a power n, b power n. But what is the difference between these two? You should know. You should know what is the difference between these two. Here the strings will generate epsilon, a power 1, b power 1, a power 2, b power 2, and so on. But here strings will generate epsilon when you put n is equal 0. When you put n is equal 1, you will have a power 2, b power 2. It means you don't have a power 1, b power 1 in the language. After that, a power 4, b power 4. Again, you don't have a power 3, b power 3 in this language. So this kind of strings are generated in this language. Again, you have a dependency in this language too, so not regular. Okay, so now when you look at this, in the exam they may ask anything like a power n, b power n, or a power 2n, b power 2n, doesn't matter. All these forms, a power 3n, b power 3n, any such language is definitely going to be non-regular when there is no restriction on n. When there is no restriction on n. If you put restriction like n less than 100, then all language will become regular. What about this? Oh, you see here a power n, b power n, c k. But there are two variables n, k. How do you analyze this? See, which is free here? C is free, right? C power k, k is free. So you just take a power n, b power n, c star, that's it. Anyhow, n starts with 0. Now this language you think about, still you have a dependency. A's and B's, n has no restriction at, n has no restriction how long it should come, that's why n will come till infinite, and there is a dependency which comes till infinite, so not regular. Okay. Similarly, in case in the future if you see something like that, a power n, b star, c power n, or a star, b power n, c power n, all these languages are also not regular. Okay, if you don't have a restriction on n, all these languages are also not regular, as there is a dependency between symbols. Yeah, can you do it? How many symbols are there in the language, or how many symbols are there in the alphabet? 2 symbols. But what is this a power n, b power n, a power n? You have a dependency? Yes. How many times? 3 times. 3 positions you will have dependency, like a's, b's, and a's. The count should be same. If a power 100 is there, then b power 100 should come, and then a power 100. It's 3 places you will have some count dependency. Can we say regular or no? It is not regular because here n is not having restriction, so not regular. Oh, what is it? A power 100? Finite language. Only one string, right? Only one string. It is finite language. So it is regular. It's just like you have one string in the language. Oh, what is this a power infinity? When you have a string, that string is infinite. Oh, such string never happens in in our language. Definitely you can't call regular. You can't call regular. It's not comes under formal language at all. Okay, it's not regular, no doubt, but also it is not a formal language too. You never see in the computation. You never see in the computation. Okay, so definitely you should think about it. We don't have such string in our languages. What you may have, so when you write a power n such that n greater than or equal 0, what do you have here? You will have epsilon, you will have 1a, you will have 2a, you will have 3a's, you will have 4a's, but you will never say that a power infinite is there. Okay, that's one of the important point. We have every string finite, but that comes till infinity, but we never write a power infinity. We never. That's not at all considered in the language. Okay, because a power infinity is not a string which is computable. Okay, a power infinite is never be computable, or you can say it's not computable string. But that's why we say it's not regular and not computable. Very special. Oh no, sometimes we write a star in the expression. In the set notation you may write a star, but doesn't matter, both are same. Sometimes we may write a star, it's okay, still same. But this is a set notation, these two are expressions. Remember, these two are expressions, this is a set notation. So even though we mix, but you should know when to write the parentheses, when to write curly brackets, when to write without parentheses, right? All are same. All are same means not in all the languages again. Sometimes writing the brackets and writing the parentheses could have a different meaning too. That I will come in context-free languages, where definitely I'll explain that too again. Now, what is the meaning of a star here? It's epsilon, 1a, 2a's, 3a's. You already know, right? It's over one symbol forms AP. It's just a star, regular. You may call simply a power n such that n greater than or equal 0. So many ways you can write. You know that a star in the expressions you can represent many ways. A star you can represent as a star dot a star, or you can represent a star plus a star. Only for a star I'm talking about. What else you can write? A star whole square, a star whole power 3, all will give you the same answer. Next one, a power n such that n greater than or equal 0. Just now I told, right? It is a star, no confusion. It is forming AP. It forms what? AP. So regular. Yeah. Now, good question. A power n square. Now try to understand the strings generated by this one. When you put n is equal 0, what do you get? N is equal 0. 0 square is 0 and a power 0 is epsilon. When you put n is equal to 1, 1 square is 1 and a power 1 is a. When you put n is equal to 2 square is 4, so a power 4 you get. And n is equal 3 you put. 3 square is 9, a power 9 you write. And observe, is there any arithmetic progression between the strings? Are these strings forming arithmetic progression? No, right? Here distance is 1, here distance is 3, here distance is 5. You don't have the distance. See, they are not forming AP. So this language is not regular, not forming AP. Okay, very interesting. Not only this, you just believe, if you know the series in mathematics, like just I'll explain what series will form AP. Like, let me write the AP series. Like when you have n, like 1, 2, 3, 4, if it is depending on n, this will form AP. If it is depending on, let's say, 2n, like 0, 2, 4, 6, 8 series, I'm putting as one form. Here you see like 0, 1, 2, 3, something like that. Just depending on purely n. And here depending on 2n, like 0, 2, 4, 6, and so on. When it is depending on 3n, 0, 3, 6, 9, this series will definitely have AP formation. And whenever sometimes even 2n plus 5, that's also fine. It will start with 5, then 5 plus 2, 7, 7 plus, 5 plus 2, 7, next 5 plus 4, it's 9. Similarly, 5 plus 6, it's going to be 11. So it will have a distance 2 because of 2n. So these things will form AP. But what will not form AP is, you should know, not in AP. Suppose we have like n square. When you have n square, the series you can understand what is happening. 0, 1, 4, 9. This series will happen. 0, 1, 4, 9. 0As, 1A, 4As, 9As. Oh, this series is very difficult, right? Which will not form AP. And what else you have? If you have 2 power n, and that I'm going to discuss anyhow. 2 power n means 2 power 0, 1, 2 power 1, 2, 2 power 3, 2 power 2, 4, 2 power 3, 8, 2 power 4, 16, this series. And similarly, prime series. Prime means will begin with what? 2, then 3, 5, 7, 11, and so on. See, there will be no arithmetic progression in the prime series. Likewise, you have different sequences which may form AP, which may not form AP. So if you know this kind of awareness, like n factorial here, n factorial, which will also not form AP, because first 0 factorial, 1 factorial is 1, then 2 factorial is 2, 3 factorial is 6. Similarly, you have lot. And these things, if you are aware, then these questions would be very easy. Now directly you can say not forms AP, so not regular. Now let's see next one. A power 2 power n. Just now I told a power 2 power n. N has no restriction. That means this purely depends on series. 2 power n series. 2 power n series not forms AP. So definitely this language is going to be not regular. In case if you want to know a power 2 power 0, that is right. 2 power 0 is 1. 2 power 1 is 2. 2 power 2, 4. 2 power 3, 8. 2 power 4, 16. So you can observe there is no common distance. So non-regular. Think about a power 2n, 2n, 3n, 4n, 5n, or 2n plus 5, 2n plus 100, 2n plus 1000. All these things will form arithmetic progression. Very simple. So this one, if you write the strings, put n is equal 0, you get epsilon. Put n is equal 1, you get 2s. Put n is equal 2, you get 4s. Put n is equal 3, you will get 6s. And this is same as even number of a's, right? So it is regular because forming AP with the distance 2 is. And obviously, I told some of the sequences, right? With that, you can easily answer the n factorial will not form AP sequence, so it's not regular. That's all you need, right? Sometimes seconds would be sufficient. Prime. I just told prime series is not going to form arithmetic progression, so not regular. Okay, in case if you want to know the strings, you already know it, but let me write a power 1 is not a prime number, so we'll start with 2, then a power 3, a power 5, 7, 9 is not a prime number, but 11 you go on. Be careful, I'm just saying it, I'll come to that slowly. Apart from this prime, if you see any other something like a power prime dot something or whole star something, so you should know what will happen. You can't answer because of just prime, it is not regular. Here only the prime, depending on prime, so I say not regular. But along with this prime, you have whole star or connecting with some other language, so you should think about it. What will be the resultant language? Right now, I can say directly, but when you are concatenate with some other combination or you are doing the clean closure or positive closure, it could change the answer. Okay, keep that in mind. What about clean closure? We are coming to that conclusion, right? So clean closure, a power 2n whole star. Can you do it? Already a power 2n is what? A power 2n is what? It's regular. But now clean closure, a power 2n clean closure. What is the meaning of this? A meaning, let me write the meaning. It means a power 2n, you can put a power 0 union a power 2n, you can put power 1 union, you can put power 2 and so on. Now look at, this is definitely epsilon, right? Union. This is same as a power 2n. Now what will happen here? A power 2n, when you write 2 times, you should know that a power 2n is same as like epsilon a power 2, a power 4, a power 6 and so on, dot this will also epsilon a power 2. When you do power 2, both the brackets are n. That doesn't mean that these two n's are same, because this is already bounded by this curly brackets. This and both are different. Both are different. That's what I said. Brackets and parentheses somewhat difficult to understand. Why? Because when somebody is saying a power 2n, actually this could lead to same n. But when somebody is saying a power 2n and a power 2n, it need not be same. Look at what I'm trying to say, right? This n is actually same, but this n not same, because it's bounded by the curly brackets. Okay, fine. Now it's actually same as a power 2n. Why? Because epsilon concatenate with all of them, you already got a power 2n. Whatever I do with a power 2 concatenation already covered by that a power 2n, and this is also going to be a power 2n, and so on. Everybody is a power 2n, power 2, power 3, power 4 and so on. Okay, so result, epsilon already there here. Why do you want this epsilon? Not required. A power 2n. So this will result simply a power 2n. Nothing but even number of a's. So it's regular with the it's forming arithmetic progression. And this is how you understand. Maybe this is easy for you, but when it comes to like a power n factorial, a power 2 power n, a power prime, this conclusion is really important, and how you approach it and how you conclude it is really needed. Fine. So it is regular. It is regular. Okay, I'll give the time for few seconds. Can you do it? A power n, where n is greater than or equal to 1. This series, n power n series, I told you, right? N factorial, 2 power n, n square. Now this one is a new one, n power n, and all this, not only 2 power n, 3 power n, 4 power n, all are actually not forms AP. The series are not going to form AP. Now this one, if you already know, you can say it's not forms AP. Otherwise, just write few strings. Put n is equal to 1, you get a power 1 power 1 is 1. And put 2 here, 2 power 2 is 4, so you'll get 4. Put n is equal to 3, 3 power 3 is 27. And you see that distance will actually not forming AP. There is no distance here, correct? There is no common distance. Hence it is not regular. Not forming AP, so not regular. Not forming AP, so not regular. Okay, fine. Let's move to the next one. Very interesting again. A power m power n. Now this is different from n power n. N power n was not forming AP, but m power n is different. Here, let's try to write the strings one by one. Now let me think about, can I put n is 1? N and m are independent, right? So I'll put n is equal 1. When I put n is equal 1, what do you get? You'll get a power m. What do you get? A power m. Of course, m is greater than or equal 1. That's fine. I don't want to put m right now because I want to show something. Union. I'll put m is equal to. What do you get? A power m power 2. Of course, assume m is greater than or equal to 1. Union, so on. Okay, so what happening here? Is this nothing but positive closure of a, at least one a? So this is already a plus, right? Union, whatever you have, epsilon anyhow you can't get it because there is no epsilon in the language at all, right? Anything you do which is equal to what? A plus. This is simply the language is like a power k such that k greater than or equal to 1. Instead of writing this, they have used two variables to form the same language. Now, definitely we'll have arithmetic progression with the distance 1, but the starting string is a. In this, the starting string is a. The language is regular. Clear? What is it? M power n power k. So now you could easily guess what I'm going to do. In all of them, I'll just conclude. Anyhow, I know m and k greater than or equal 1. Just I take in one case, I just take n is equal to 1, k is equal to 1. I will get a power m, that is actually a plus. Now do the union with any other case. Do the union with any other case. Right, what do you get? You should get a plus. Because this is a superset. Whatever you get, which has to be subset of this. Like in WW case we did, right, when you have x. The same way, you just think about when you have many variables over a, then you could use the same technique. Fine. A plus is regular. And I can say that this could be the question and previous question could be the option. Because which of the following is equivalent? This is also equivalent to a power m power n without k, right? So you can think about it because that is also giving a plus. Okay, now a power n whole star. A power n whole star. Already a power n means we'll have all the strings over a whole star is also going to get all the strings. Anyhow, let me check that. Epsilon, a power 2, a power 3 and so on, whole star, which is also equal to, see already this a is enough to produce everything, right? A star will give you everything, so you don't need to go for each one, right? Or you can take power 1. When you have the power 1, you have a base string. Then no need to take power 0, power 2, power 3. All are covered by the power 1. So it's your choice. How do you want to think about? So I'm just showing it. Then you have all the strings a power n power 0. Here a power n power 1. Here you have a power n power 2. Likewise, you have a lot of options, right? You do the union. Is just equal to a power n what you have here. So which is equal to basically a star. A star is regular. A star is regular. Now a star whole star. That's simply whole. Just now we have seen, right, the similar one. A star only, regular. A power n square whole star. Is there any case which can give a star? Yes. Put n is equal to 1 here. Just think about one case. Put n is equal to 1. What do you get? A power 1 square is 1 whole star. That means I have a star. Then take any value of n which is already generated by when n is equal to 1. That's by a star. Okay. So it is regular. See how easy if you know the concept. I'm just looking at the language. Do I have every string in this language? Yes. In one case I have. The remaining cases, whether you take it or not, this case already covered. So this case is superset for any other value that you take. Okay. If I put n is equal to 2 square is 4, a power 4 whole star. That can't cover everything, right? So this is the best example that you can take. This is the best example. A power 3n. A power 3n whole star. Now you think about a power 3n. What is it? A power 3n. will it give you again a power 3n? Just seen that in a power 2n. So now let's think about it. A power 3n. So there are two ways to write. Sometimes even I do represent differently. So now I'm talking about when n is equal to 0. When n is equal to 0, what happens? Why I'm putting n is equal to 0? The reason is, writing this one slightly different from this one. So you should know exactly how do you represent. So when you represent this way, so I'm just using my notation such that n greater than or equal to 0. This notation would be appropriate. Okay, when you have this, the n has to be fixed before the star. N is equal to 0. What happens? When you put n is equal to 0, put 3 0, that is a 3 times 0 is 0. A power 0 whole star is epsilon. Now when you put n is equal to 1, that's a power 3 whole star, which is a power 3 whole star, which is actually gets the same meaning as a power 3n only. Okay, a power 3n only. N is equal to, that's a power 6 whole star. Of course, it's different, a power 6n. And when you do the union, that a power 3n would be sufficient to cover all of them. So simply you can say a power 3n, okay, which is going to form arithmetic progression. So regular 3n will form the AP series. Okay, n factorial, again a power n factorial. So let me write in a better way, a power n factorial whole star such that n greater than or equal to 0 or 1. 0 factor and 1 factor are same here, so you can take 1 also. Now let me write n is equal to 0 or 1. 0 or 1. You get what? A power 1 whole star. So a star. Take any other value. Doesn't matter. N is equal to whatever you get. Like a power 2 whole star. N is equal to 3. The 3 factorial is 6. So a power 6 whole star. And you do the union. When you do the union, which is equal to a star, so it is also regular. It is also regular. I'm going to give some homework questions for you. You should practice the homework questions, and definitely in case if you don't understand the question, please discuss below this video. If I see your comment, definitely I'll reply to your comment. Okay, so this is your homework. I'm just writing in better way to understand a power n whole star such that n greater than or equal to 0, but 0 power 0 is undetermined, so you can start with 1, but I'm putting 0, but don't take 0 as it is not possible to understand the 0 power 0. Now a power prime whole star, I told you, right? A power prime whole star. You should, previous one was homework, take it as homework and let me know whether it is regular or not. A power prime whole star, and prime number you already know it, right? So here how you analyze it. Okay, this is let me put in another way. A power k whole star such that k is equal to prime. That's a better way to write. Now I'm going to analyze for you what's gonna be here. Like, put the primes. What are the prime numbers you have? 2, 3, right? 2 or 3 or 5, 7, 11 and so on. Let me put them one by one. So when I'm trying to put them, this is equal to, put 2, you will have a power 2 whole star. Okay, union, put another one, a power 3 whole star. Union, a power 5 whole star. Union, a power 7 whole star. Union, so on. I just want to check what is going to happen to the language. Can I generate every string in a star or only some strings? If I can generate some strings in a star, will it be regular? That's my target, right? I told you Even though a power prime is non-regular, but a power prime whole star may be regular, that you need to check. Now, my question is very simple. I'm just focusing on a star. What is a star? Epsilon should generate, a should generate a square, a power 3. I'll keep on checking to understand how many are possible here, right? I'm just checking. Epsilon, can I generate everywhere epsilon is there? Here, power 0, power 0, power 0. Everywhere epsilon is there. So I'm getting it. Single A. Can I generate single A from anyone? See, when I take power 1, I'll have 2 A's. When I take a power 1, I'll have 3 A's. When I take a power 1, I'll have 5 A's. So I don't have single A. So this is not possible. So I can't write here. A square, a power 2, I can have here because power 1 can generate. A power 3, I can have here because when I have a power 1, because looking at all of them is very difficult to understand, right? So I'll just look at the string and I'll look at who is generating that. A power 4 next, because I want to know a power 4 is generated or not. A power 4 I can generate from here by taking power 2. In place of star, I can take power 2. A power 2 is what? A power 4. A power 5 here, power 1. A power 6, 2 places you can write. Here you can take a power 2 power 3 or a power 3 power 2. But anyhow, a power 6 is possible. Similarly, a power 7 here. A power 8, directly not there, but you can see 2 you repeat how many times? 4 times. You get a power 8. A power 9, you can repeat 3 times. A power 3 power 3. Now a power 10, repeat this 2 times. A power 11, 11 is already prime, you will have directly. A power 12, here you can have, or here. So you have every string after this. But look at what is missing. Missing is only one string, that is single A. So this language is actually complement of A. If the language is A, its complement is going to be this L. Understand? The complement of A is going to be a power prime whole star because only A is not present. So in case if you want to represent better way, this one is actually equal to a power n such that n not equal to 1. That's it. See how easy to represent. Or you may say is equal to a power n such that n is equal to 0 or n greater than or equal to, except 1. I want to have every value of n. That is how I can represent another way. So this is a very simple to understand. And if you want to write an expression, this is equal to, you want epsilon because 0 is there, yes. You don't want a, but I want at least 2 a's. After that, any number of a's is fine, right? 2 a's, 3 a's, 4 a's, 5 a's you can generate from here. And except a, I will generate every string from here. Okay, so it is regular because I have written expression to help you, and you can always design a DFA for single A to accept. So its complement definitely possible by interchanging final and non-final. Okay, so with this we have almost completed regulars and non-regulars. So anything else that you can see, take it as homework. I've already solved it, and let me know what is this language, regular or non-regular. Okay, I've already explained it. And homework, a power m, b power n. Very easy question. A star ash a star. A power n. Homework. Very simple. A power n followed by a power n is a power 2n. Okay. Dependency is there. So what do you answer? A power n plus 1, b power n plus 2. We have dependency. So with this, we have come to some conclusion that now we are comfortable in languages. Some are regular, some are non-regular. But you should go back and look at what did I explain in the beginning of this lecture. Like language, if it is finite, it is always regular. If it is infinite, sometimes regular, sometimes non-regular. When it is regular, if there is over one symbol and forming AP, or there is no dependency, or there is no dependency if you have more symbols. When it is non-regular, in case if it is having one symbol in the alphabet not forming AP, the language is not forming AP, then it is non-regular. In case you have more symbols in the sigma alphabet, you should look at dependency and you should also look at whether it forms AP or not. Okay. In previous lecture, we have seen regular expression and DFA. Now let me explain non-deterministic finite automata, so that you will have a complete concepts with the regular languages. Non-deterministic finite automata, which is definitely easier than deterministic in construction oriented. But why do you prefer DFA rather than NFA or NDFA? You may say it's NDFA or NFA. Why do you prefer DFA? Because at the end, when it comes to reality or practical, the DFA would be appropriate for implementation. And in case you are taking much time to solve the problem, then solve the NFA first, then you convert to DFA. Because NFA to DFA, the algorithm exists. If you have a finite automata, either you can approach DFA or you can approach NFA. As you know, there is a relation between these two. Every DFA is already NFA. So those deterministic machines you have designed in finite automata, they're already called as NFA. But every NFA you may not call, because sometimes DFA, sometimes not. So by definition, every DFA already NFA, so you don't need to convert. It's already converted. But if you have designed NFA which is not DFA, you must know how to convert it. So there is algorithm called as subset construction. If you want really you learn, here I am going to construct only NFAs, not the algorithm. So subset construction is there, where every NFA you can convert into DFA. Now let me help you. In the NFAs, the delta definition is Q cross sigma, which is 2 power Q. If it is NFA with epsilon moves, there is another NFA without epsilon moves. Sorry, without. This is without, right? Without. There is another NFA with epsilon moves. With epsilon moves means without reading input also you can change the state. Here input you must read, but in NFA with epsilon moves you have another choice. You can also read epsilons. Either you write sigma epsilon as a subscript or you write union epsilon. Both are same, which is 2 power Q. And this is the main difference between the NFA without epsilon moves with epsilon moves. But obviously when you have 3 machines, DFA, NFA without epsilon moves, move means transitions, without epsilon transitions, NFA with epsilon transitions. Remember, all these are NFA only. Yes, they are NFA. Every DFA is NFA. This is already NFA, this is already NFA. Only the thing is, when you design these things, they may not be DFAs. Okay, so it's a very important. Every DFA is already NFA without epsilon moves. Every DFA you can call it as NFA with epsilon moves. But when you have this two, to convert into other direction, you need algorithms. You need algorithms. Here, if you want to convert with epsilons to without epsilon, you require some algorithm. And there is an algorithm to convert directly from here to here. There is another algorithm required. So this algorithm may not help you for the competitive exam point of view, but if you know it, sometimes which will help you to realize the concepts in the exam. So I will recommend that at least you know one example how to convert from one to other, and remaining will help, you don't need much practice for them. Fine, let's construct NFAs without epsilon moves. Okay, this is a very important point where you require for the exam point of view. So I will help you how to construct NFA for a given regular language. How many states in NFA that accepts empty language over binary alphabet. So always I will help you one thing. If you want to construct DFA would be easy or not, I will help you. Here for empty language, it's okay. It just take some, one or two states, you can approach DFA or NFA. But when they ask you how many states in DFA, you should answer in DFA. How many states in NFA, you should approach NFA concept. Then what is the main difference between DFA and NFA? What is the main difference? You should know it. Okay. See, when you are talking about DFA, your focus is from every state, for every input symbol, you should have exactly one transition. That means Q cross sigma goes to Q. It means from every state, for every input symbol, exactly one transition. That means if I have two states, two input symbols, you will have 4 transitions in the machine. Whereas in NFA, Q cross sigma, for every state, for every input symbol, what is this means 2 power Q? It means anything can happen. You may not have a transition. You may have a transition. If even you have a transition, it could be 1 or 2, 3, anything. So it's 0 or more transitions to the next states. Okay, here Q means only one transition to the next state. So very important difference between this is from each state, for every input symbol, exactly one transition. From each state, for every input symbol, anything could happen. 0 or more transitions. Okay, that's why we have the all possibilities here. We have all possibilities. Now come to the point. Now when you design it, empty language, right? So let me explain first DFA. Let me explain first DFA. In DFA, what did you do? Over binary alphabet, let me take sigma is 0, 1. Binary, right? A, B, X, Y. Just take 2 symbols. Empty language is this one, and you have written 0 or 1. That's it. Correct? 0, 1. This is DFA, which is just one state. And it is definitely minimum DFA. No doubt. The first question itself will give you very important theoretical concept and definitely needed for the exam. When you want to design NFA, NF, that's going to give you empty language. When other combinations are not giving any valid combinations, then you don't need to cover them. 0 or 1 is not compulsory. See here are one more. 0, 1, 0, 1. That's same as that one. All these are minimum NFAs, where all of them are having one state. Because NFA says that if the string is valid, you should have at least one path. If the string is invalid, you don't need to have 0, or you don't need to have the transitions. See, I know on zeros, anyhow it's not accepting, so I may not cover. Even I cover sometimes, I may cover more than one if I want it. In all of them, the definition of NFA is preserved because all the combinations that are leading to invalid, so don't worry about it. So here minimum DFA is only 1, but here all are minimum NFAs. This is also minimum because one state, all are minimum NFAs. So what do you know about this? No, everybody is minimum here, but not all the times. Remember, this time here, this is minimum NFA, only one state, minimum NFA, minimum NFA. How do you know all are accepting same language? There's no final state. Here Q cross sigma should be mapping to Q. Here Q cross sigma mapping to 2 power Q. You may ask, sir, what is Q cross sigma looks like here? Suppose this is A, then A comma 0 delta is empty set. A comma 1, it is empty set because empty set is belongs to 2 power Q, right? But here if I say, let's say A, here delta of A comma 0, it's A, that belongs to Q. A comma 1 is equal to A, that also belongs to Q. A belongs to Q, but empty set belongs to 2 power Q. And when it comes to here, if let's say this is A, delta of A comma 0 which is A. That's set A is belongs to 2 power q, and A comma 1 is empty here. Similarly, you can try for every machine that I have designed here. The first point, for every regular language, how many minimum DFAs? Only one. Here, for every regular language, you can't say unique. You can't say only one. Need not be unique. Sometimes maybe one. You don't know, right? Depends on the language. And here, the first point, if you take a regular language, for every regular language, first point, unique means only one. Unique minimum DFA exists. But how many NFAs? Need not be unique. One or more, you say that. Need not be unique minimum NFA. Okay, that's the important point. So I may have one NFA sometimes minimum NFA, or it could be sometimes more than one, depends on the language. I hope you understood, but still a definition not complete for the NFA. Let me explain what NFA does exactly and DFA. If it is DFA, you give a string. If this DFA accepts L, what happens? If W belongs to L, exactly one path. Exactly how many paths? One path halts at final. Remember this? Exactly one path. As you know, every symbol you take one transition, another symbol one transition. So one by one, it will create only one path. And even it not belongs to L, you will have only one path. You don't have more paths. Exactly one path that halts at non-final. That's the concept of DFA. That's why you should cover the dead state. You should not miss any transition from any state, because you need to cover every input symbol from every state. That's why we have the exactly, you know that if there are 100 states, I have 5 input symbol, you can say how many transitions, because unique. The size of Q cross sigma is going to decide number of transitions in the DFA. Whereas in the NFA, somewhat different definition. Here focus is on only the valid strings. Suppose NFA accepts L. What happens? It's only worried about W belongs to L. It will never worry about not belongs. But I'll write both of them. But this is only important for you. If the string is in the language, what is it? At least one path. Not exactly, I don't need to say exactly. At least one path. It may be one, it may be more. We don't know. At least one path exists that halts at final. That's all the definition is. If the string is valid, you will have at least one path that will halt at final. What happens? Invalid string will never go to final at any case. But for invalid string, you may not have a path also sometimes. So I'm just writing it, but this would be sufficient. I'm saying for valid string at least one path. For invalid string, you may not have a path. You don't know, right? This is derived from this statement only. Using this statement, I'm writing another statement, but really not required. If W is not in L, you may have 0 paths. You may have more than 0. If you have more than 0 paths, definitely it should halt at non-final. So remember that 0 or more paths. 0 or more paths. That's first point. If there is any path that should halt at non-final only. If it is halting at final, that is definitely valid string, right? All set, non-final. This is the NFA definition. That's why designing DFA could be easy, but if somebody designed for you, it might be difficult to understand. This is a very important. For DFA, designing could be difficult, but if anybody designed, you can easily understand. because it looks like very deterministic and clear and no confusion at all. Non-deterministic is, not clear much when somebody designed for you. Okay, let's focus on the second question. Can you design an NFA that accepts L? Now, what is the minimum string? A. So first, simply you follow your form, A followed by A plus B whole star. You require A accepted, then followed by A comma B. But is this the only machine you have? No, right? Can design many other machines too. But how do you design? Okay, let me help you. Before that, did you remember DFA? What is it? Starts with A. A you accept. After that, everything is accepted. But if it is not starting with A, you should go to dead state. This is your DFA. In DFA, you will say 3 states, but in NFA, you say only 2 states. You may ask, sir, why are you not covering for the B? Because any string which is starting with B is invalid for me. My definition says if the string is valid, then you will have at least one path. If it is invalid, I don't care. If it is invalid, I don't care. So maybe the string here starting with B is invalid. That's why I'm not covering. So I know that string is never starts with B. That's why I don't care. Okay. So here in NFA, dead state is not compulsory. In minimum NFA, you will never have a dead state. So look at that. NFA may contain dead. But when you want minimum NFA, please don't keep dead whenever it is not needed. Okay. Never require dead state for the minimum NFA at any cost. So 2 states. Now I told you already. For every regular, you will have only one minimum DFA. Every regular, how many minimum? DFAs? 1. But if you want to have a DFS, you can design 100,000, 1 lakh. But minimum DFA will be only 1. DFAs are many, infinite. But minimum DFA is 1. Minimum DFA is 1. But here, minimum NFAs could be possibly 1 or more, I said. So now, let me try. Is there any other NFA? Still, it will accept the same. Okay. So do not worry. It is the minimum NFA. I am designing one more NFA. Look at, observe. Will change the answer now. See here carefully. Will it change the answer? Suppose I have A. I have B here, state name. Now, let's say string is W is equal to AA. Is it valid? A followed by A? It's valid because starting with A. But how many paths will have? At least one path. No need to be exactly one. Here exactly one path is there. But here I will show there are many paths. Among them, at least one path halts at final. Look at that. Double A. You can go to the A on first symbol A and then you can go to the B. So let me try many paths. A on A. Again I can go to A. Doesn't matter. A is the one path. What is second path? A on A is A. On other A I can go to B. What is the third path? A on A I can go to B. Another A I can go to B. Among these 3 paths, is there any path halts at final? Yes, that would be sufficient to say the string is valid. No need to say all the paths are halting at final. Among these paths, at least one path exists true. It halts at final. That halts at final. Yes, this is halting at final. This is halting at final. This is not halting. It's fine. Among these 3 paths, at least one path halts at final. That means it is valid string. That's why here any string that halts at final will definitely starts with A. Either this A or this A, doesn't matter. But don't think, sir, I am halting at non-final. That means it is invalid. Oh, never say that. That's not the definition of the invalid string. Invalid string says that I will never have a path that halts at final. That statement is very clear. Or you can say, if I have a path that should halt at non-final. If I have a path that should halt at non-final. Right? So, but is it halting at non-final all the time? No. Clear? So always remember one definition. If the string is valid, that should halt at final only. But how many paths? 1 or more. But among them, at least one path should halt at final. Remaining may halt at final, may not halt at final, but at least one path should halt at final. That is how, these two, any string you take, Both are doing the same behavior, but somebody might have more paths, somebody might have one path. That's fine. Okay, but every valid string, you will have at least one path in both of them. That all set final. That all set final. Fine. So both are. This is also what? Minimum NFA. Keep on trying. You may have many other minimum NFAs. Like on A, I'm here. Here on A, I can go there. Still, the answer, I will have two paths. Still, I will take this one to accept if I want it, right? So there are many other minimum NFAs. I don't want to construct here a lot, but I want to show that yes, need not be unique minimum NFA for every regular language. The answer is two states. Can you try ends with double B? Okay, here the NFA will be very easy to design rather than DFA. Let me design. Ends, right? See, A plus B whole star. So I can put A comma B as a self loop and followed by BB. So I can follow my expression to design NFA without worrying much like a DFA. That's enough. But there are many other NFAs too. Clear this point? So how many states in an NFA that accepts L? So I'm directly answering it. How many? 3. Of course, I didn't keep the options as I just want to explain DF and NFA both. 3 states. In the exam, mostly preferred DFAs. Some cases, I saw very simple examples, very simple languages where NFA could be asked. Then just design it like starts with A, ends with B, starts with double A, ends with double B. Few simple questions, you should be in a position to answer both DFA and NFA. How many states? Containing double B. Containing double B, just follow the same. Like A comma B and then B followed by B. And now you can keep final because after that any number of A's and B's can come in the sequence. Now this will require just 3 states. If I give options 1, 2, 3, 4, just take the answer 3 states. Is it same for a DFA? Yes, DFA also would be 3 states. DFA also will not require dead state. Just try yourself. But diagram will be different. See, is this DFA? No, right? On B you have 2 transitions. But in DFA you will never have that. In DFA either you will have this or you will have this. Only when you design DFA you will know it. So this is not a DFA at all, even though you have 3 states. Okay. This third symbol from beginning is A. Already we did that in DFA, but in NFA how do you do that? First length A comma B, second length A comma B, and third symbol, that is A. If it is not A, you are going to dead state in DFA, but here we don't need to cover. Dead state will give you additional 1 state, and actually NFA says that if the invalid string, no need to cover the path if you're really not required. Okay, A followed by any sequence of A comma B's. How many states? 4 states in NFA. In NFA, how many states? 4 states. But in DFA, you will require 5 states. The same question, if I say, okay, nth symbol from begin is A, right? This is your heading for both DFA and NFA. For DFA, how many states you require? Extra dead state needed, so 5 states. Minimum DFA, and minimum NFA just require 4 states. So here 5, how did you get? Third symbol you get 3 plus 2. So here instead of 5, what do you write? N plus 2 in general. Your third symbol you got a 4 states. You will have here, you don't need a dead state, N plus 1 states. So similarly, you can compare both DFA and NFA, and I have some homework questions for you to construct NFA. Obviously, you could have seen a lot of examples to construct NFA, but I feel that you have already constructed DFA. NFA could be very easy. Just follow your expression to understand. The next one is that third symbol from ending is A. And please take homework for DFA. DFA takes a lot of time to design this. I'm just writing the formula, but you just do the homework for both of them. This one, nth symbol, here it's third symbol, right? Nth symbol from end or RHS from end is A. When this is your question for over A comma B, sigma is what? A comma B. In DFA, how many states you require? Really, it takes a lot of time. 2 power n states, exponential time. If you have nth, you are looking for nth symbol, it will take exponential time to do that. 2 power n states. But NFA, just nth symbol, right? Look at how easy it is. Just follow the same sequence. First, A comma B as A plus B whole star. Then A, this is assumed as the third symbol from the end, and the second last, and this will be the last. As it is a non-deterministic machine, very easy to design. But if you want to construct DFA, it's gonna take time. And here how many states? 4 states. That third symbol, 3 plus 1, nth symbol, n plus 1. See that? Are you looking for from beginner end? The NFA is always giving you n plus 1 states. But in DFA, if you are looking from the begin, n plus 2 states. If you are looking from the end, 2 power n states. And this was already asked in the GATE in previous years. So you can remember these concepts, but you have an homework. What is homework? Please construct the DFA for this. How many states you should take? Third symbol from ending is A. 2 power 3. 8 states should take. Okay, 8 states. Already you got an answer, but just need to construct. May take time, but you will remember this concept for a long time. Okay, please take homework. I'm not answering it. Length of the string is equal to 2. That means 2 length strings you are doing, right? Exactly 2 length strings. Exactly 2 length strings. Just look at DFA, NFA, how many states you are taking. If I'm looking for length of the string is equal to n, and this was also one of the GATE question. So maybe let me solve for you for exactly 2. But take some less than or equal to, greater than or equal to as homework. Length of the string is equal to, so 1 length and then second length you accept. After that, don't care, because 3 length, 4 length are invalid for me. No need to cover any path for them. So this is NFA. How many states required? 3. So when I ask length of the string is equal to n, how many states required here? The n plus 1 states in NFA. In NFA, minimum NFA. Whereas in DFA, it was the PYQ, GATE PYQ, they mentioned A plus B n times. That means n length strings. To accept this n length strings, how many states required in DFA? Here, see one here, the last state, the A and B transitions are missing, that will go to dead. That will go to deads. So extra 1 state, that is n plus 2. That's all. The one dead state path is missing from this state. So add the transition on A comma B to the dead state, that would be fine. So 1 state is a dead state extra compared to NFA. Okay. And please, this is what I'm talking about. Take homework. And just generalize less than or equal n for DF and NFA and concept it and write a formula for that. But if you want to solve it, just take 2 or 3 to solve it, to understand. And greater than or equal to n, again take it as homework. Equal to n I have solved for you, but solve for both DF and NFA. Now look at this, containing double A or double B. It's a very special problem for me, because containing double A, containing double B, containing double A or double B. See that question. First you should know containing double A. That already solved it. If you want it, see that. Contains double A as a substring. Very simple, right? Just take A comma B, A followed by A, and after that A comma B. This is a containing double A. But this question is not just containing double A. It could be possible or containing double B. See that? You know the expression, right? So containing double B. Then how do you expand it? Just either this path or I'll go to this path. That's it. Now you have containing double A or double B. How many states you have? If I mention 3, 4, 5, 6, so you will have 4 states. Even in DFA also, what happens? Double A or double B. And here you have A comma B transition, so you don't take the self loop. And here you will be having almost same states there also, but transitions would be different compared to this one. You want to design that? This is NFA. How easy it was. But DFA, if you want design, how do you try it? So minimum string is double A or double B. Double A or double B. You should take different path for both double A, double B, but same final. Why? Because when you see double A or double B, you will not have any job to do. So finally you have to do one thing, that is accept every sequence once you see double A or double B. But before that, you should ensure either you will see double A or double B, then only come to final. Now in this process, it takes a little bit time to cover the missing transitions. See, this state has A and B both. You will not think about them in DFA. Here A is there, but B is not there. From this state, what do? After A, B comes, then B followed by B is a valid string. So B comes, you will go this side, so that B followed by B, there's a possibility of having double B. Clear? That's why we go this side. And here A is missing. B, after B, if A comes, then stay here. So followed by A, you can go to final state. That's it. Answer is over. Now look at it, from every state, you will have 2 transitions, one for A, one for B. That's why it is DFA. Okay. So anyhow, the machine looks different, but this is also NFA, this is also NFA, but this is DFA, but that is not DFA. Look at what I'm saying. It's DFA, so NFA. Every DFA is what? NFA. Every DFA is what? NFA. So there is no confusion that in the world, every DFA is NFA. But if it is minimum DFA, may not be minimum NFA, because it might have dead states, right? It might have, different number of states. Like if you look at third symbol from ending is A, 2 power 3, 8 states. But that's minimum DFA, is not minimum NFA. So this point is also important. When you have a minimum DFA, it need not be minimum NFA, may or may not, depends on the machine. Okay, this is the minimum DFA, but this is also minimum NFA. But this is minimum NFA, but not minimum DFA. Okay, because it's not a DFA at all. Okay, understand. Okay, another important question really asked in the gate. I've just modified the question. If all states of NFA are accepting states, in the NFA, let me take something. All states in NFA, this is NFA, because here A is missing. If my sigma is only A, sigma is having only A, this is not a DFA at all, but it is NFA. All the states of NFA are final states. Is it accepting sigma star? No. Okay, just assume it is in a sigma star. Is it accepting sigma star? No. Only it is accepting epsilon and A. Double A is not having a path here. Double A is not having path here. Whereas if I have something like a DFA, DFA, let's say this one, all the states are final. If all the states of DFA are final, then it has to accept sigma star. Why? Every string you will have exactly one path in the machine. If every string is halting at final, then every string is accepted in the world. Then L is equal to sigma star. So which statement is true here? Which statement is true here? The second statement is true and the first statement is the false. Because in NFA, if you have all the states are final, it may be sigma star, it may not be. So this statement is false. You should say, and you should say like, then the language accepted by the NFA need not be sigma star. Don't say not sigma star. Need not be sigma star. That is a true statement. So by looking at these two statements, which one? Only 2 is a true. Okay. Yeah. Thank you so much for watching the last 2 lectures. In the first lecture, we have covered finite automata and regular expressions along with the basics. And In the second lecture, I have covered regulars and non-regulars along with the non-deterministic finite automata. Yes, still there is a lot to learn in this theory of computation. In case if you have any doubts, please comment below this video and discuss all your doubts to have a clarity what you are learning. And thank you so much. See you in the next lecture.